In this video, I will cover Full Stack Developer Toolkits. A full stack developer is a developer who can build a web application from the ground up, from the backend server-side code and database code to the front-end JavaScript and HTML code. Full stack developers are in high demand, and the demand will continue to increase in the future years due to the comprehensive skill set required to design an entire web app by a single individual. In terms of a JavaScript full stack developer, we can break down the front-end technologies into frameworks such as React and Angular and Vue.js, as well as Bootstrap and Materialized CSS for a responsive front end that scales effectively over various device types and screen sizes. React and Angular and Vue.js are all frameworks based on JavaScript, which enables a more organized and quicker way to design the functionality of a front end. Bootstrap and Materialized CSS can be used to help speed up the visual design of a front end, such as the buttons and colors and text sizes across various device types and screen sizes. jQuery is also another important front-end JavaScript library used for traversing HTML documents and handling events and animations easier. Finally, Ajax is used on the front end to make API calls and to update a web page without having to completely reload it. Backend frameworks run on the server side, and in terms of JavaScript, the most popular backend framework is Nodejs. The nice thing about Nodejs is that it uses traditional JavaScript, which many front-end developers are familiar with. Node.js is an asynchronous JavaScript runtime which is designed for scalable applications. Express.js is a Node.js framework which comes with middleware and routing improvements to Node.js. Happy.js is another Node.js framework which helps reduce time to develop the backend by reusing application logic. Sales.js is a model view controller or a Ruby on Rails-like framework, and it comes with a service-driven architecture as well as support for data-driven APIs in order to help create enterprise-level Node.js web apps. JavaScript frameworks can also be used to develop desktop and even mobile apps. PhoneGap is an open-source version of Apache Cordova distributed by Adobe, which is designed to enable developers to build mobile apps with CSS, JavaScript, and HTML. PhoneGap apps can be built to run for multiple device types such as iOS and Android phones. React Native allows developers to build cross-platform mobile apps using only JavaScript and the React front-end JavaScript framework. Meteor Js is an open-source JavaScript framework built using Node.js. It enables developers to write one code base and use it across mobile, web, and desktop applications, and it was designed in order to speed up prototyping and reduce development time. A full-stack developer also has to be familiar with tools such as Git, GitHub, Bitbucket, and Subversion. Git is the most popular version control system in use today, and it's used to store source code in a distributed fashion for a project. GitHub is the primary central repository for all the code on the internet. Bitbucket is similar to GitHub, except that it offers more of a team collaboration environment, supporting things like private self-hosted repositories for enterprise users, Jira support, continuous delivery, and code review tools. Subversion is another version control system which is different than Git in that it holds all its information on a centralized server and you need an internet connection to use it at all times. npm is the most popular package manager for JavaScript and is used extensively with Node.js. Yarn is a newer JavaScript package manager intended to be faster and more secure than npm. Babel is an open-source JavaScript compiler which can compile JavaScript to make web apps written in newer versions of JavaScript compatible with older JavaScript engines. Finally, Webpack bundles assets such as JavaScript, text, images, HTML, and CSS into static modules to better organize a web app and to create a dependency graph between resources. Once your full-stack web application is developed and tested, it is time to think about putting it in production. The majority of full-stack applications today are deployed in the cloud. This speeds up the infrastructure and platform setup and also creates a reliable environment to maximize uptime. To deploy a full-stack application, you can use platform as a service products such as Amazon Web Services or Heroku, and Heroku uses more of a container type setup. Or if you want to manage the infrastructure yourself, you can use products such as DigitalOcean to deploy your app. Stack test automation framework to run tests on a Python Django full-stack web application. Some features which are must-haves for full-stack web test automation frameworks include cross-operating system and technology compatibility, cloud testing capabilities, quality of documentation, ease of troubleshooting or finding problems, as well as the ability to extend or customize the test automation framework libraries. The most important tests in test automation are unit tests, regression tests, and integration tests. Unit tests verify the functioning of individual components. Regression tests confirm that past bugs in the code are no longer present, and integration tests verify that the different components work together. In Django, there is a test framework built on the standard Python unit test library. It is useful for both unit as well as integration testing. The Django testing framework also adds API methods along with tools to test for specifications found in Django. There is also the option to integrate with other popular web testing frameworks such as the Selenium browser automation testing framework. To write tests, you can derive from the unit test or Django test base classes and then write separate methods to check the functionality of the code. So let's take a look at our project first. In the browser, in localhost port 8000, we're just running a Django application, and you can see it's just a simple library. So I could click on all books to look at all the books. I only have one book in my book list. I could click on test book 1, and I could see that one's on loan and one's available. I could see the summary, ISBN, language, and genre of the book. I could also click on my borrowed books for my logged in user BMISLJN, and I could see that I have test book 1 on loan, and then I could click all borrowed to see all the borrowed books and the user that borrowed the books, and I could renew my borrowing of the book. So it's a very simple full stack Django web application. Now I'm just going to go open up PyCharm and take a look at the code. So in terms of the unit tests, I have 3 files. I have test_forms.py, test_models.py, and test_views.py. So test views is simply created to test the actual views that the user sees. So basically making sure, for example, that we get a redirect if not logged in, checking to make sure that the user is logged in with permissions for another user's borrowed book, and so on. We also have the model tests. So this is more just confirming that the database fields and models are correct. And we have the form tests. So basically, this just goes on and just checks that the form fields that are actually displayed to the user are all correct. So if we're renewing a book, making sure that we have an invalid form if the renewal date's before the current date. Another thing I want to mention is you see here we're importing on line 1 from Django.test import test case. So that's the base class from Python. We're importing date time as well. And then we're importing our renew book form from the forms in this case. And we have that test case base class that we're extending upon. So in order to actually run the tests, we could go into a command prompt. And what we're going to do is we're just going to type in Python space manage py space test. And we're going to go ahead and run our tests. We could see the dots for all the past tests, and then F means that an individual test has failed. So once that's all done, we see 2 tests that failed. We're going to get a summary, and then we'll be able to look at the tests that failed and go and fix them. So the first test that failed was in test_models.py line 43, and we got an assert equals failure. So let's go to test_models.py in PyCharm in line 43, and we could see that we're basically searching for the models test last name max length. So what we're doing is we're basically looking at the author, and we're looking at the last name, and we want to ensure that the max length is 100 characters. So if we go to the models.py file for the database models, we could see that on line 107, the last name max length is actually 90. So let's change that to 100 and save that. Now we could go back and see what our other error is. So our second error is saying that in test_views.py line 287, we have an invalid assertion for a return status code. So let's go to test views line 287 in PyCharm, and we'll scroll down here and look at 287. So that's in the test_form invalid renewal date future. So that's basically saying that this is testing that if we take a book out and we have to renew it, we're only allowed to reserve it for up to 4 weeks. If we reserve it for more than 4 weeks, it's an invalid date. So on line 284, we're simply putting 3 weeks in, which is actually allowed. That's legal to reserve it for 3 weeks. So we want something more than 4 weeks to make the test work. So let's put 5 in here. If we put 5 weeks and we go ahead and we save that and we run that API request, we should get this assertion on line 288 where we basically get the status code of 200 and saying invalidate renewal more than 4 weeks ahead. So let's go back and actually test if we manage to fix it. Now what I'm going to do is I'm going to specify Python manage py space test and then -- verbosity and 2. So verbosity just gives us the level of detail that we want to display when we're running our test suite. So it goes from 0 to 3. I'm going to specify 2, and this is just going to give us more outputs, which test failed, which test passed in our command prompt. So we'll be able to see it, and we could see here OK for each individual unit test that's running. So here we see ran 40 tests in 10.941 seconds and OK, meaning that all the tests passed. So we managed to fix our code and our test cases, and now all our test cases are passing. So that's just a very simple example of how we could write some unit tests and do test automation with a Python Django web application. In this video, I'll identify full stack developer testing methods. There are various limitations in testing a full stack application. Misunderstood requirements is one of them. If the requirements are misunderstood, a full stack application may be developed up to specifications and all the tests may pass, however the application may not do exactly what the client intended it to do. Another limitation is regarding time and resources. Proper testing includes not only functional testing but also performance testing, UI testing, and so on, and these are all non-functional tests. If a full stack project is on a tight deadline or is understaffed, many of these tests may be omitted for sake of time efficiency. Acceptance criteria may also be missing. This is common if the QA team does not effectively communicate with the developers writing the full stack web app, or if the acceptance criteria from the customer or client is not clearly indicated. Finally, software testing is not predictive in a sense that it is never possible to predict the future and the demands which will be placed on a full stack application. The best time to start software testing is during the development phases of the application. If errors and bad architecture decisions can be caught early on, they can be corrected at a minimal cost and impact to the customer. Some of the factors to consider when developing a client testing plan are how long it would take to come up with and implement a test strategy. This needs to cover how to do end-to-end tests and how to simulate situations in order to complete them. For example, testing the functionality which uses an API call without the actual API existing yet. Testing time is another factor. This should include not just the time to do standard functional tests, but also allow time for workarounds in the case that the traditional testing approach doesn't work in some cases. Troubleshooting costs are another factor to consider. Whenever a defect occurs, it needs to be reproduced in order to be fixed. If defects are caught early on while the application is still in development, the troubleshooting costs will be significantly lower. A complete full-stack testing cycle involves the QA team reviewing testing and functionality requirements with product owners, managers, as well as working closely with developers in order to understand the functionality of the application. Once that is done, a test plan can be put in place, and that can go through an architecture review to verify that everything is being covered and tested in the proper way. If this process is followed and communication between QA developers and product owners is good, it will lead to an understanding of the test case requirements, which can then be implemented by the QA team. There are two types of tests that can be run against a full stack application. These are functional and non-functional tests. Functional tests are comprised of tests that check to make sure that the application is behaving like expected. For example, by clicking the Buy Now button on an e-commerce store and then an order will be placed. Non-functional tests are just as critical as functional tests because they test things like load handling, performance, speed, and stability to ensure that users get the best possible experience using the application. Performance tests load an application up with simulated workload and then check the speed and stability. Speed tests issue test commands or calls from a simulated user and check and see how fast these requests are processed. Load tests generate simultaneous calls from multiple test users in order to test the speed of a real-life production run of the application. Stability tests often run over the course of a few days and are designed to check how an application handles a sustained load with peaks and dips of load depending on user requests. Some other non-functional tests include scalability testing, security testing, usability testing, and industry standards compliance testing. Scalability tests are often used on clustered applications run in the cloud to ensure that the response times remain consistent with an increasing of the load. There is often a time aspect with these tests as well, in which an application is expected to scale its resources up or down in order to meet an increase or decrease in simulated user demands. Usability testing is a bit of an art form. It tests the overall user experience of an application, such as the sequencing of menus, the colors, fonts, and text sizes, to ensure that users get a logical and easy-to-use experience. Industry standard tests include things that are commonly expected functionalities from users. An example of this would be a login prompt, which requests a password and username, or a picture upload button, which brings up a file browser to select a picture. Security tests are very important tests which ensure things like SQL injections, cross-site forgery requests, and security cookies are used. These tests are often missed but are vital in ensuring that users' private information is protected against malicious attacks. In this video, I'll go over full-stack performance testing and will compare full-stack performance testing methods. Performance testing, often also referred to as perf testing, is a type of non-functional testing in which a load is applied to an application and the scalability, stability, along with the responsiveness of the application is analyzed to ensure that the application can endure real-world stresses. Performance testing enables bottlenecks in an application to be discovered and fixed in order to ensure a consistent user experience across various application load levels. There are various types of performance tests, including load testing, stress testing, volume testing, capacity testing, and reliability recovery testing. Load testing is a performance test where an application is tested with requests at normal predicted usage and at peak predicted usage rates, and the response rates are measured. The network, database, and APIs are all tested, and response times are analyzed. The application should respond within a time tolerance at both the peak loads and at the normal load levels over a sufficient period of time, such as a few days. If the application has issues with responsive performance with the higher load levels, load testing can help in improving the database, network, processing, and storage architecture of the application. Similar to load testing, stress testing applies a load to an application starting with a normal load, and then it gradually ramps the load up to a point where the application can no longer handle it and it starts to fail and not respond to requests. This exposes the weak points of an application and also how it recovers from an overloaded scenario. The major difference between load testing and stress testing is that stress testing tries to break the application while load testing tries to verify the endurance of the application at high load levels. There are various types of load tests, including application, transaction, systemic, and exploratory. Application stress tests deal with performance bottlenecks in the application, as well as things like data blocking and network problems. Transaction stress tests are used to optimize transactions or requests between different applications in a system. Systemic stress tests are run on all applications on the server at the same time. They can reveal information on how different applications work with one another and share data. Exploratory stress tests are used to test unusual scenarios such as a database failure to see how the application will handle unplanned issues. Capacity testing is used to test business cases and basically figure out the load scenarios that are currently happening and that might happen in the future. Things such as memory, disk I/O, and request processing parameters are closely monitored to ensure that an application can meet projected as well as current demands, and that it can also support an increase in demand in the future. Actual usage data is very useful for capacity planning as well as capacity trends. An example of this could be an e-commerce store, which sees 70% more requests and logged in users during the holiday season compared to the summer months. Volume testing tests the performance of the database when it stores a large amount of data. For example, if you build a social media application, you may only have a handful of users at first. As the popularity of the application grows over the years, the number of users will increase along with the size of the database. By doing volume testing, you can test and see the response times with a greater volume of data and identify any potential database bottlenecks. And this could be resolved, and then the speed could be increased. So volume tests can either be incremental, where the volume of data in the database increases gradually, or steady, where a constant level of data is kept in the database for the test. Reliability and recovery testing ensures that if an unexpected scenario occurs, such as database or server failure, that the application is able to recover and return back to normal operations. The time required to recover is another thing which is measured, as it is important to have minimal service disruption and downtime to users. For example, if you were to try and go to YouTube for your lunch break and watch a video, and the server is down due to too many people uploading videos, and then you later went on and watched that video in the early afternoon, it can be said that YouTube is reliable as it is recovered from the server outage. In this video, I'll go over how to use security testing in order to help secure a Django full-stack web application. Security is one of the most important considerations when developing a full-stack web application. In the years 2016 and 2017, there were over 4.2 billion personal accounts compromised due to inadequate web app security. By using test cases targeting security, a full-stack web app can harden its level of security. In Django, there are certain security features built in, such as cross-site request forgery or CSRF, SQL injection, clickjacking, SSL, HTTPS, and host header validation. Some of these security features are enabled by default, and others need to be turned on manually through the settings.py file in the Django project. The built-in command python manage py check --deploy is offered by Django in order to check the overall security of the web app before deploying it to a production environment. The command, when run, prints out a list of potential security vulnerabilities on the command prompt, and that can be used to fix some security issues that have been overlooked. And what we're going to be doing now is we're just going to go ahead in our Windows command prompt. We have here our full stack testing Python virtual environment, and we're in our full stack test library full stack application written in Django, and we're going to run the python manage.py check deploy command, and that's simply going to print out any security vulnerabilities that we have in our project. So we could see we have 8 issues. So if we take a look at the first one, it says you have not set a value for secure HSTS second settings. If your entire site is served only over SSL, you may want to consider setting a value and enabling HTTP strict transport security. The second one says your secure content type no sniff setting is not set to be true, so your pages will not be served with an x-content-type-options no sniff header. You should consider enabling this header to prevent the browser from identifying content types incorrectly. So what we're going to do is we're going to try to fix these 8 errors, and then we're going to rerun python manage check deploy, and then we're going to launch the application and see if it's working correctly. So let's go ahead and open up our code here, our settings py file in pycharm, and we could see up here the first thing I'm going to want to do is for any type of production environment, I'm going to want to turn off debug mode. So I'm going to uncomment this line on 27 that sets debug to false. So basically I want debug mode off. I'm also going to want to make sure under installed apps, I go ahead and install SSL server on line 43. Now, the way we install it is we open up our command prompt and we simply type pip install Django-SSL server. This is going to allow us to actually test HTTPS in a local environment, because the standard Django run server only works with HTTP. It doesn't support HTTPS. So let's go back, and once that's installed, we're going to make sure it's under installed apps here on line 43. Then we're just going to scroll down, and at the bottom I have some security settings. So I'm just going to uncomment my security settings, and I'm going to explain them. So starting off on line 156, so we're going to set the secure content type no sniff equals true. So this basically ensures that the browser doesn't guess the content type. It's going to use the content type in the header instead, which is going to increase our security. On line 158, secure browser XSS filter is going to be set to true. So that's going to block all suspected XSS or cross-site scripting attacks on our web app. On line 160, X-frame options will be denied. So we're not going to deny displaying any parts of the site in a frame, which could also help with security. On line 162, CRSF cookie setting will be true, so we're only going to set CSRF cookies over an HTTPS connection. Similar on line 164, session cookie setting true, so only send session cookies over HTTPS. And we're going to secure, and then on line 166, we're going to set secure underscore SSL underscore redirect to true, which means we force all requests over HTTPS. Finally, we're going to activate HSTS and set a value to 1 year in order to force request over HTTP to go to HTTPS, and that's also going to reduce man-in-the-middle attacks. So we're going to use the command on line 169, secure underscore HSTS underscore seconds, and we're going to set it to a value of 1 year. And then we're going to include all subdomains as well with the secure underscore HSTS underscore include underscore subdomains equals true command on line 171. And finally, we're going to add the preload directive to HTTP headers for HSTS with the secure underscore HSTS underscore preload equals true. So once that's all done, we're just going to go ahead and save all. And we're going to go back to our command prompt. And then we could go ahead and run our Python manage py space check -- deploy command and make sure we get no issues. So we have now secured our app. And then what we're going to want to do is we could run Python manage py run SSL server. So this is actually going to run that SSL server package we installed. And we could see now that we could actually access our site at HTTPS 127.0.0.1 port 8000. So I'll just copy that address in and I'll throw it in the browser. And we could see that we're now accessing the site over HTTPS. Now it says not secure because we don't have a valid SSL certificate. That could be done with the SSL, with the run SSL server command prompt. There's an option after to specify your own SSL certificate. So if you do have a valid one, you could get your browser to accept that, and then you won't get that warning that the SSL certificate's not valid. So that's how you could run some basic security tests and basically configure the security settings of a Django web app. Go over how to use the Selenium browser automation test tool in order to test the views of a full-stack Django web application. Selenium is an open-source web browser automation testing tool which has been around since 2004. Over the years, it has become the most common automation testing tool due to its support for many modern languages such as C# and Python, its extensibility, and its cross-compatibility across multiple IDEs. We can add Selenium WebDriver to our Django project for our library by using the pip package manager in our virtual environment. So if we run the command here, pip install Selenium, it should install in our full stack testing virtual environment Selenium. And we could see it's already installed. So once that's done, what we could do is we could go ahead and actually open up PyCharm and take a look at our Selenium test. So we're going to create under our test folder, we're going to create a new file called selenium_tests.py. And inside here, we're going to define our Selenium tests for our web browser. So you could see up top, we just have a few imports. On line 3, we're going to import live server test case. So that's basically going to launch a Django server instance, which Selenium is going to talk to. We're also going to import the Selenium WebDriver, which is going to execute our code through Selenium on line 4. And we're going to import the keys from the Selenium WebDriver. Then we're going to create a user test case class with the live server test case base class. We're going to have 3 methods: setup, tear down, and test add users. Setup on line 10 is just going to set up the Selenium web browser. So depending on which WebDriver extension you want to use, I want to use Chrome for my browser, but if you want to use Firefox on line 11, you would specify .firefox. I have .chrome. And another important thing is that I had to install the Chrome WebDriver, so I downloaded that. It's available on the internet for your version of Chrome. And then you basically need to extract it in a directory and put the path of the Chrome driver.exe file, which is used to run that WebDriver for Chrome, which is needed for Selenium. So that sets up Selenium. To tear it down, you simply call self.selenium.quit on line 15. And here we have our test case, test add user on line 18. So basically what the test case is going to do, it's going to log in to our library Django full stack web application.
it's going to go to our accounts login page. Now notice that I'm specifying get url_lib.parse URL join self.live server URL. Now this is important because the URL is actually different for Selenium. It uses port 8081 instead of 8000, and the live server URL actually gives you the active port for Selenium. So that's a good command to use for the command to get the URL. And then I'm using url_lib.parse URL join to add the accounts login, which is the path for my login. So then I'm going to get the username, password, and submit buttons by name and by XPath on lines 27, 28, and 30. Then I'm going to send some information into these buttons. On line 33, I'll send the username, password, and then on line 38, I'll try and log in. Now this is going to fail, so I'm going to want to reset my password. So I'm going to find an href and click it for the reset of password. Then I'm going to enter my email in the email field, and then I'm going to click the reset email button. And then that's going to return on line 51, emailed you instructions. It's going to be in the string. I'm going to assert that that's in the page, and then the test will be successful. So let's go ahead and run it. I'm going to go ahead and run the test. So Python manage py test catalog.test.selenium tests. And that should launch a browser in Chrome. So first it's going to load up Google. I just have that to show that we could actually load up any type of URL. And then after 5 seconds of sleeping, it's going to load up our login page. So now it's going to find the username and it's going to enter it in. It's then going to sleep for 2 seconds, enter the password, and attempt to log in. That's going to fail, so it's going to go over this lost password href. It's going to enter it, and then it's going to get the email instructions. And once that's done, we have the OK message, and Selenium is shut down. Our browser window is closed, and we see that our password reset test has worked for the UI. We can now check our email and see if we got that password reset email. So that's all for using Selenium with Django to do some UI testing on our views.
In this video, I will compare full-stack database testing methods. Databases are used by almost every full-stack application in order to store user data. The way the data is stored, organized, and accessed can be the difference between a properly functioning application and one which is problematic. Database testing is often not the first type of testing that comes to mind, as there's no visual or graphical aspect to it, such as in user interface testing. It is, however, vitally important to include in a test plan for a full-stack application. There are different types of database tests, including schema testing, table testing, trigger testing, and functions testing. Schema testing is used to verify that the relationship or mapping between the front-end user interface structure and the back-end database structure is aligned. Table testing ensures that the database field types and names match the specifications, and that the user can insert, modify, and delete data of the appropriate type in the database, and that the appropriate private key and foreign key constraints are present in the database table. Trigger testing involves ensuring that the appropriate database actions are taken on trigger events, such as insert, delete, and update. Functions tests ensure that functions written by the development team adhere to specifications. Functions tests can check things like the formatting of data used and returned from functions, handling of null or default values, and whether exceptions are handled appropriately. There are three major types of database testing. These are structural, functional, and non-functional. Structural testing primarily uses queries in order to test things like the database tables and columns, schema, stored procedures, and triggers, as well as the database server and other elements found within a database that the end users are not able to access. Functional testing is meant to test the database and make sure it meets specifications from a user point of view. An example of this could be verifying that a field is mandatory or allows null values and ensuring that the fields have adequate size. The two common types of functional tests are white box and black box. White box testing is testing where the tester doing the testing knows the internal structure of the database, and black box testing is where the tester only knows the expected inputs and outputs. Non-functional database tests are used to test a database's performance. These are including load testing, security testing, stress testing, and usability testing. Structural testing is composed of schema testing, database, table, and column testing, stored procedure testing, trigger testing, and database server validations. These elements are the backbone of the database and are not exposed to end users. Schema testing, as I mentioned before, is related to the mapping of the front-end user interface to the back-end database structure. Database table and column testing ensures that the front-end user interface, data field types, and lengths match those of the database, and that all the fields from the requirements are being used. Stored procedure testing ensures that the developers followed the coding conventions, that data is passed in the proper format, and that all exceptions are handled appropriately. Trigger testing involves ensuring that actions such as update, insert, and delete work when updating the database. Finally, database server validation checks the database server is configured to requirements and that the number of transactions which can be handled and security permissions are also match any customer needs. Functional tests are run by testers to ensure the user has the experience that is outlined in the system design requirements. Testers can either send data via the user interface and verify that it is stored correctly in the database, or they can update the database and verify that the user interface is working correctly. Data should be logically organized in the database and properly trimmed, and any failed transaction should not update the database. Login and security tests can test if a user enters incorrect username or password information, and they're not then granted permission to access the database. Tests can also check that the user only has the level of privilege granted to them, and that they can't modify the database items outside their level of privilege. Passwords and sensitive information stored in the database like credit card numbers should also be encrypted. Non-functional tests are used to test the overall performance of the database. Examples of non-functional tests include stress tests, load tests, usability tests, security tests, and compatibility tests. Stress tests are meant to break a system, and in case of a database, the number of queries can be gradually ramped up until the database stops responding. Load testing applies various levels of queries to a database over a longer time frame and ensures that the database responds in a consistent manner. Both stress tests and load tests can help in removing performance bottlenecks. Usability testing or UX testing deals with the user interface and making sure it's friendly to users. Example of this could be adding help text to forms that update database fields from the UI. Compatibility testing is testing the ability of a database to run on different hardware, operating system, or software versions for the different configurations. Finally, security testing can be used to verify that a database is secured from outside attacks, as well as malicious authenticated users, and that all or any sensitive information in the database is encrypted. In this video, I will compare full-stack usability testing methods. Usability testing, also known as UX or user experience testing, is testing where a small batch of specialist testers use a system as an end user would in order to expose any issues with the ease of use of the software. Questions such as where to click next, whether menus and registration processes follow logical flow, and which error messages are displayed are all analyzed by testers in order to ensure that system design requirements are adhered to. The flexibility to handle various controls and achieve the desired outcome is also assessed by the testers. The testers need to have not only a sense of the system requirements, but also artistic taste, since oftentimes usability testing can be subjective. Advantages of usability testing are that the user problems can be discovered and fixed in development before a product is shipped to production. End user satisfaction is also improved as the system is easier to use, menus and forms are more logically organized, and navigation's improved. This helps to streamline user efficiency and effectiveness, which not only helps raise user satisfaction but can also reduce the number of requests or load on a system. Finally, the feedback received in usability testing is representative of real-world users, so that there is less bias than there would be if only the developers reviewed the system. Examples of failure of usability can be nonsensical UI layout, where, for example, the login button is hidden in the top right-hand side of the page instead of being in the center. Confusing navigation flow is another one. An example of this can be an e-commerce site which asks you to pay before you enter your shipping address. Meaningless icons and jargon can also complicate the UI and take the user's attention away from the stuff that really matters. Inconsistent error messages are a big issue, as the end users need to know as much detail what they're doing wrong and how they could fix the problem the next time around. Insufficient session time is another one. An example of this could be when you are booking a hotel room and you get a timer which only gives you 30 seconds to input your credit card number, or you lose the reservation. There are various parameters that usability testers look at when testing a system. The system effectiveness deals with things like the length of time required to learn a system, the actual value or use the system has to end users, along with the visual aspect of the system such as fonts, colors, images, and icons. Efficiency includes things like having search functionality, having uniform menus and page templates across an application, as well as having clear and concise navigation, which takes you to the appropriate page with the least amount of navigation required. Accuracy deals with things such as having your application up to date, not having any broken links or outdated addresses, phone numbers, or missing images. User-friendliness consists of things like having the ability for an average end user to use and navigate through the application with ease, the presence of help text along with detailed error messages, which help to reduce training time required for the end users. Usability testing can be completed in a 5-step process. The first step is to create a test plan and determine the major goals or functionalities that you want your usability test to cover. In the planning phase, you can also determine the number of testers required and the demographic of testers you want to employ along with their experience. The next step is to recruit the appropriate usability testers, which match the demographic and professional experience you require for your usability tests. This step often takes more time because it might be hard to find the testers with the experience you require. After that, the usability tests are executed and data is collected. The data is then analyzed and conclusions on how the system can be improved are formulated and presented to key stakeholders in the project, such as developers, managers, clients, and graphics designers. In this video, I'll compare full-stack API testing methods. API, or Application Programming Interface, is a set of tools, subroutines, and communications protocols which is used for communication between two different software systems. An example of an API commonly used with web applications is the REST, or Representative State Transfer API. Testing APIs, unlike testing the user interface, doesn't deal with the visual look or feel of the application, but instead tests business logic by sending inputs to the API and recording the output, ensuring that it matches the expected actions. An API exposes functions or subroutines which, when called with data, invoke a communication operation between systems. For example, with the REST API, there may be a method to add a database row, which will take the values of the row and then call the REST HTTP post method, which will transmit the data to the other system. In order to test APIs, access to the API is required, along with either custom test code or access to third-party tools such as Postman or curl. When an API is called, it should return output to verify if the operation succeeded and which operation took place. API output can include any type of data, a pass or fail status, or a call to a different API method. For example, with a REST API, if you invoke the GET method, you will pull data from a server and that data will be returned to you. If you call the POST method, you will add data to a server and get a response code to indicate if the POST operation succeeded or failed. A succeeded operation, for example, would have a code of 201 for creating a resource, while a failed operation error code might have a code like 400 for bad syntax on the client-side request. There are various test cases that can be formed for API testing. As I mentioned in the previous slide, we can check the return value for specific input conditions and verify that a successful or unsuccessful return value or status code is returned depending on an input condition. If there is no return value, the actual system needs to be checked in order to verify that the API did indeed do what it was intended to do. An example of this could be checking a database table after a POST API request to ensure that a new row was added. If the results of an API request causes some other event to be triggered, it is important to track not only the original API call, but also any calls that result from the API request. An example of this can be an API request to get if a user is valid and then to trigger a URL to log that user in. Anytime a data structure is modified based on an API call, there should be a test in place to ensure that the data integrity of the data structure is not compromised, and as well that data memory limits are not exceeded. If an API call updates or modifies a resource, such as all the rows in a database, then another API call can be used to get all the modified resources in order to verify their validity. There are 3 major steps when approaching API testing. The first step is to understand how the actual system works and the scope of the API. Once that is done, the range of the input data can be divided into equivalent partitions or equivalent classes, of the same expected outcome, and boundary tests can be generated to test values at the edges of the equivalent partitions, as well as at the extreme minimum and maximum values of input data. So basically with the equivalent classes, it means that if we have a wide range of data and we have the same expected output for a set partition of that range, we could divide that into classes, and that saves on the number of input values. Error guessing can be applied from past tester experience in order to expose vulnerabilities in the API by inputting data which may cause unexpected outputs. Once all the input data and test cases have been decided upon, the coding of the test cases can be started. The third step is to execute the test cases and to compare the test case data to the actual data and fix any errors present. Proper API testing is composed of various components, the first of which is discovery testing. In this stage, the tester would run manual tests on the API using tools such as curl in order to see if an API is able to add, update, delete, and list resources. The next stage is usability testing, where the testers can verify if the API is user-friendly and intuitive to use. An example of this could be that the API auto-trims input data if it is surrounded by spaces. Related to usability testing, thorough documentation of all the API methods is required. This will help users unfamiliar with the API get up to speed quickly and will ensure that any changes to the API are visible to the end user. Security testing can test things like authorization levels for users to call certain API methods and whether the API uses an HTTP or HTTPS connection to send data. Finally, automated testing is required in order to have a repeatable testing environment which can be executed on a daily basis to ensure that all existing and any new additions to the API behave as expected. Various third-party tools can aid in API testing. RunScope runs API monitoring on all the APIs of a system in order to gain quick insights on any downtime or API issues. Postman is a complete API development environment which allows you to manage every step of an API's lifecycle, from the design, implementation, monitoring, debugging, and automated testing. SOA Test is a scriptless REST and SOAP API testing platform which uses machine learning to tune tests as application services change. SOA Test also transforms functional tests into performance and security tests. Curl is a command line tool for transferring data using various protocols such as HTTP, HTTPS, and FTP, and can be used to test API requests from the command line. .test works with Visual Studio tools and scans an application's entire codebase looking for errors before the application goes into production. CTest is built for testing applications and APIs developed in C. It develops automated functional testing suites based on application specifications. Go full-stack web application by the use of Docker containers. A Docker container is a lightweight package or container of software which contains all the runtimes, tools, code, libraries, and settings required to run a piece of software. Containers can be used to isolate software from surroundings and help in minimizing conflicts between people running different types of software on the same infrastructure. In order to install Docker on Windows 10, Enterprise Edition is required. If you do not have Windows 10 Enterprise Edition like myself running on your PC, you can install the Docker toolbox instead. Docker Compose is a tool that can be used for running multi-container Docker applications, and it does come pre-installed in Windows with Docker Toolbox. So the first thing we're going to do is we're going to open up a Django project called Full Stack Test. So that's the one where we have basically our library application, which we used in some previous demos. We have a list of books and we could check the books out and so on. And we're going to want to deploy that in Docker and run the tests. So here in PyCharm, you could see I have my project. I'm going to want to add 2 new files for Docker. So under the root full stack test directory, I'm going to add a Docker file with no extension and a docker-compose.yaml file. So inside my Docker file, if I open it up, we could see here that on line 3, I'm simply specifying which version of Python to use. And then I'm setting the Python buffered environment variable to 1, which basically means that the Python output is going straight to the terminal without buffering. Then I'm going to create a new directory called catalog_service. That's going to be a root directory for our Django project in the Docker container. And then on line 13, I'm going to set that directory as the working directory. And then I'm going to add all of the current directory contents. So from my Django project root directory to that container root directory.
And finally, on line 19, I'm going to run the pip package manager. I'm going to install all the requirements .txt, so all the requirements for my Django project, which are listed inside the requirements.txt file. So once that's all done, I could then create a docker-compose.yaml file. So here what I'm going to do is I'm simply going to specify the version that I want for the syntax checking of Docker Compose. So that's version 3 in my case, the services. So I'm going to have two services. I'm going to have a database. I'm going to use the Postgres database instead of SQLite for my Docker container. So I'm going to specify the image as Postgres, and that'll be downloaded and installed by the Docker container. And then I'm going to specify the web, which is going to be my actual deploy settings. So it's going to be, my command is going to be bash-c python manage py make migrations for my database, and python manage py migrate, and python manage py test. So I'm going to run all my test cases, my unit tests, which I went over in a previous video, as well as python manage py run server, and I'm going to specify 0.0.0.0 and a port 8990 where I could connect, and I'm going to select the volumes to catalog services. That's that directory I created. And finally, the ports 8990, and it depends on the database, the Postgres database. Finally, once that's done, there's just one last step before we could go ahead and run this. We're going to go to our settings py file. And up top, we're going to want to make sure that we allow all the hosts just for testing. So on line 31, we're going to set allowed hosts to the wildcard star character to allow every host. Then we're going to scroll down, and I'm going to set the databases. So I have a variable at the top here on line 17, docker equals true. On line 82, I'm checking if docker. If that's the case, I'm going to set the Postgres database as the database we're using, and the host is going to be db, which is defined in the docker compose file as the service db. And I'm also going to set an else statement just using this SQLite database if we're not using Docker. So once that's all done, I'm going to go ahead and open up the Docker toolbox in Windows 10. And one thing we could do is we could check the Docker machine IP. So that's actually going to give us the IP address of the Docker machine, and we could use that to access our URL. So it's going to be 192.168.99.100 on port on the port that we specified, which in this case is defined in Docker Compose as 8990. So once that's done, I'm just going to make sure that nothing's running. So I'm going to run Docker Compose stop web. Once we stop it, I could go Docker Compose run web. And so that's going to start and run that script that we created, the Docker Compose script. So we could see that we're going to try applying the migration. So this says no migrations to apply. We're now running the tests. We could see the dots for all the unit tests. There's 40 unit tests that we're running as part of our Django project. So it created the test database, and it's running them. And after the tests are complete, it's actually going to go ahead and launch our library application in the container, and we'll be able to use our browser to navigate to it and make sure that everything's working in the container just as it would in our local environment. So let's just wait and see how these tests complete. And once that's done, we're going to see if it launches properly. Okay, continue. So we could see that it says ran 40 tests in 51 seconds, and it says okay. Then it destroyed the test database, and it launched on the HTTP 0.0.0.0 port 8990. If I open up my web browser, I could see if I go to my Docker container address, so 192.168.99.100.8990 catalog, I get my web app, my Django web apps launched just as it would if I ran it locally outside of the container. So that's how you could go ahead and do some full stack testing and deploying a Django application using Docker. In this video, I'll go over how to use the ELK Stack log management platform to analyze the logs generated by a full stack Django web app. The ELK Stack or Elastic Stack is the world's most widely used log management platform. The ELK Stack is composed of 4 open source products, which are Elasticsearch, Logstash,
Kibana, and Beats. Elasticsearch is used for text analysis and search. Logstash collects data from various sources and aggregates it after transforming the data, and then it sends it to the output destinations. And Kibana works above Elasticsearch and allows users to get a visual representation of log data. Beats is used on edge hosts to collect different types of information which can then be sent into the stack. One of the easiest ways of installing the ELK stack is by using Docker through the docker-elt git repository. So basically what needs to be done is this repository just needs to be cloned into a directory. And then once we're inside the repository, we could run the command docker compose up. And that's going to download all the sources and install our ELK stack. Once that's done, what we want to do is we want to type in docker ps, and that's going to launch up a list of all the running Docker containers, and we should see 3 containers up. So we're going to see the Docker ELK logstash container, and we could see that's on port 5000. Then we're going to see the Docker ELK Kibana container on 5601 and the Elasticsearch container on 9200. So what we're going to do is we could open up a web browser and we could go and to our IP address of our Docker containers 192.168.99.100, port 5601, and that opens up Kibana. Now what we're going to be able to do here is we're going to be able to import our logs from our full stack Django application and actually import them and view them visually in Kibana. So what we want to do is we want to scroll down in Kibana and go to management. And under management, we're going to get some options. We're going to want to go to index patterns and basically define a new index pattern. But before we do that, let's go ahead and take a look at our log files. So under our full stack test, our Django library catalog application, we have a debug.log after the debug settings for logging are turned on in Django. And we're logging in a certain format with the date timestamp. So we could see here, if I open the log up, you could see on line 491, we have a timestamp of 2019-07-12. We got a time, and we basically have the message afterwards. So we're going to be able to import this into Logstash, and then we're going to be able to actually go ahead and we're going to be able to view it visually by setting various filters on the timestamp. So how we go ahead and import this is that in the command prompt, we're going to want to run the nc command, which is basically not native to Windows, but you could download it as a third-party application. So I'm just specifying the path to my nc command and the IP address and port 5000 for Logstash. So basically what that's going to do is that's going to take this document that's after the caret, so my debug.log, and it's just going to post it. It's just going to put it in Logstash, and then that'll be able to be discovered by Kibana. So what happens now is that after I execute this command and debug.log gets sent in, I could go back to my web browser and I see I have my Elasticsearch. So basically that log that we got sent in, it's going to go into Elasticsearch, and then Kibana is going to see on top of it. So I could click on index management in Elasticsearch, and I should see that I have my Logstash indexes or logs in here. And once that's in here, I could go ahead under Kibana and create a new index pattern, which is going to allow me to actually view my log. Okay, continue. So we could see here under Elasticsearch and index management, we have our Logstash logs that we sent in using the nc tool. So basically we could see the size, 837 kilobytes, and the docs count, and so on. Now what we want to do is under Kibana, we want to click on index patterns, and we're going to want to define an index pattern for our new Logstash. So I'm just going to go ahead and I'm going to delete this existing Logstash index pattern, and we're just going to start from scratch so I could show you how to define a new index pattern. So what we want to do is we want to click on create index pattern, and that's going to search for Elasticsearch data. So once again, that data we imported. Then we want to set Logstash -*, and it says success, your index pattern matches one index.
So then we could see that it's matching the index that we saw in Elasticsearch. So we want to go to next, and then we want to click on create index pattern. And actually, before we do that, let's just set the time filter stamp. So we're going to filter based on timestamp. So we get the logs in a sequenced order by timestamp, and we'll be able to view them by timestamp. Once we do that, we could click create index pattern. That's going to create our index pattern. And once that's done, we could click on this discover icon at the top left of our Kibana web dashboard. And what we could do now is we could click on a time range. So we could click on last 15 minutes, for example, and I'm just going to click on my log stash filter that we created. And you could see here that I'm getting my messages. So you could see here I have 394 at 15:08:30, and I could scroll down and I could actually look at the various messages I have in my log at the various timestamps, and I could change the time scale. So I could click on last 30 days, for example, or I could click on last 1 hour and just get the proper time scale so I could view all my error log messages, and then I could click on each message and get the information based on timestamp for the debug messages. So that's how we could go ahead and analyze some Django full stack web app logs using the ELK logging stack.
Now that we are all done our videos, it is time to do some practice. In this exercise, you will list full stack toolkits, describe full stack software testing, describe full stack performance testing, describe full stack database testing, and describe full stack API testing. Now pause the video and perform the exercise, and I will get back to my solution. Full stack toolkits can be broken down into front-end technologies, back-end technologies, mobile, and other technologies, as well as deployment options. In terms of JavaScript full stack developers, we can break down the front-end technologies into frameworks such as React, Angular, and Vue.js, as well as Bootstrap and Materialize CSS for responsive front-end that scales effectively over various screen sizes. Backend frameworks run on the server side, and in terms of JavaScript, the most popular backend framework is Nodejs. Express.js, Happy.js, and Sales.js are examples of other backend JavaScript frameworks. Meteor Js, React.js, Cordova, and PhoneGap are all examples of frameworks for developing cross-platform mobile, web, and desktop apps using the JavaScript language along with HTML, React, and CSS. The majority of full-stack applications today are deployed in the cloud. Examples of cloud deployment options include Amazon Web Services, Heroku, and DigitalOcean. There are various limitations in testing a full-stack application, so these include misunderstood requirements, lack of time and resources, and missing acceptance criteria. Factors to consider when developing a test plan include how long to come up with and implement the testing strategy, as well as the testing time and troubleshooting costs. To build a test plan, the QA team needs to review testing and functionality requirements with product owners, managers, and developers. Once that is done, a test plan can be put in place, and that could then go through an architecture review. There are two types of tests that can be run against a full-stack application. These are functional and non-functional tests. Functional tests are comprised of tests that check to make sure that the application is behaving like expected based on the business requirements. Non-functional tests test things like load handling, performance, speed, and stability to ensure that users get the best possible experience using the application. Some other non-functional tests include scalability testing, security testing, usability testing, and industry standards compliance testing. Performance testing ensures that an application can handle real-world stresses and loads. Load testing is where an application is tested with requests at normal predicted usage and at peak predicted usage rates, and response rates are measured over several days. Stress testing applies a load to an application starting with a normal load, and then it gradually ramps the load up to a point where the application starts to fail and not respond to requests. Capacity testing is used to test business requirements for real-world scenarios of both normal and peak loads. Things such as memory, disk I/O, and request processing parameters are monitored to ensure a system can meet current and forecast demands. Volume testing tests the performance of the database when it stores a large amount of data in order to expose and fix any database-related performance bottlenecks. Reliability and recovery testing ensures that if an unexpected scenario occurs, such as a database or server failure, that the application is able to recover and return back to normal operations. The components of a database can be broken down into 5 pieces. These are hardware, software, data, procedures, and a database access language, such as SQL. There are various types of database testing, including schema testing, table testing, trigger testing, and functions testing. There are 3 major types of database testing. These are structural, functional, and non-functional. Structural testing primarily uses queries in order to test things like the database tables and columns, schema, stored procedures, and triggers, as well as database server and other elements found within the database that the end users are not able to access. Functional testing is meant to test the database and make sure it meets specifications from a user and business point of view. Non-functional tests are used to test the overall performance of the database. Examples of non-functional tests include stress tests, load tests, usability tests, security tests, and compatibility tests. When an API is called, it should return an output to verify if the operation succeeded and which operation took place. API output can include any type of data, a pass or fail status, or a call to a different API method. There are various test cases that can be formed for API testing. We can check the return value for specific input conditions and verify that a successful or unsuccessful return value or status code is returned. If the API causes some other event to be triggered, it is important to track not only the original event, but also any further events that may have been triggered by the API. Anytime a data structure is modified based on API call, there should be a test in place to verify the integrity of the data structure as well. There are 3 major steps when approaching API testing. The first is to understand what the API and the codebase actually does. Once that is done, the range of input data and types of tests can be decided upon, and the coding of the test cases can be done. The third step is to execute the test cases and to compare the test data to the actual data and fix any errors present. Proper API testing is composed of various components, including discovery testing, usability testing, documentation testing, security testing, and automated testing. Various third-party tools can aid in API testing. Examples of third-party tools include RunScope, Postman, SOA Test, curl, Dot, and Ctask. So that's all for our exercise. Just to go over what we talked about, we listed full-stack toolkits, and we described full-stack software testing. We described full-stack performance testing, then we described full-stack database testing, and finally, we described full-stack API testing.
In this video, I'll talk about API development with a focus on the benefits of using Python as an API server for full-stack development, or FSD for short. I'll start with a few things about FSD, in terms of a tool perspective rather than an overall strategical perspective. We'll get right into the tools. So this is a common high-level structure. So FSD is client, and in terms of the client, we usually think of it in terms of JavaScript as our language inside of a web browser with HTML and CSS and frameworks like jQuery or React or Vue or Angular. And then we have a server layer. What we're going to focus on in this course, although it's entirely possible to implement the server in many different languages and frameworks, in JavaScript or PHP, Ruby, Perl, etc., I'm going to look at Python. And rather than implementing a page or HTML template render engine on the server, we're going to look at an API server. And the other major part of full stack development is data persistence. So this is the data storage in SQL, relational databases, or NoSQL data stores. Or we could have key value stores and caching and logs and other data that needs to be accounted for, and that we think of that as the data persistence layer. So these are the 3 main layers of FSD, and of course each of these can be separated out and broken down into smaller parts and tools. But in this course we're going to focus on the server portion in Python implemented as an API. So what are some of the common API types? So the ones we deal with most often in FSD, we have SOAP. So this is the Simple Object Access Protocol, which communicates in XML. We have REST, or what we call Representational State Transfer, GraphQL, which is an API language for querying data, and RPC, or Remote Procedure Call, which is often implemented in custom ways, depending on the application and tools you're using. The APIs I'm going to demonstrate in this course are not going to follow a strict set of rules or frameworks, but it will build up to a point where you could implement either of these 4 types based on the scaffolding I'll provide, starting with the video titled Python Flask API Scaffolding. So why Python? Well, it's one of the most popular languages with a large community. It has a thriving ecosystem, It has package repositories, and it's been around for nearly 30 years, since 1991. It's also become a go-to tool for data science, with many APIs supporting Python as their main interface language. So tools for data wrangling like pandas, data science with scikit-learn, numpy, and scipy, and deep learning and neural nets with TensorFlow, Theano, and Keras. So it's widely used, and it's tried and tested for many years. And then in this course, I'm going to focus on Flask. So it's a Python web server application framework. It's a micro framework, something like Django, which is more opinionated with batteries included, which I discuss more in the video titled Python API Framework Choices, where I compare popular frameworks including Flask and Django. It's extensible, and it's well documented. So it's known for its scalability, its simplicity, and that it's very lightweight. So in the video titled Python Flask API Scaffolding, I'll build up the structure of a Flask server application for API deployment. And that concludes this video discussing Python API development with a focus on Flask. In this video, I'll describe the guiding principles and some methods behind RESTful APIs. Although REST APIs are not the only way to implement a Python API, you can set the stage for your own application, for your own approach, if you understand some of the principles behind REST. The good news is that it's okay to mix systems here. This is not a fixed approach, but it's better than not having a common structure to start with. So if you like it and it works for you, then it's entirely possible to keep your API within the REST guideline. So let's start by talking about the guiding principles behind implementing REST APIs. Well, we have a client-server architecture. So this is separating concerns of the user interface from that of the server logic and data persistence and storage. So the server doesn't render the UI, the client takes care of that. So the client and server can be developed and evolved more independently. Statelessness is another principle. So part of the independence of client and server in REST comes from its statelessness. So no client context is stored on the server between requests. The cacheability, so quite often the GET requests, if no data has been changed, can be cached. So quite often the web server takes care of this even before it hits the application API. The data can be returned immediately, so that performance and scalability is improved. And it's a layered system. There are often multiple layers of application, web server, app server, caching server, database server, scheduled job services, etc. All of these are working together to improve the application, but all layers act independently of the client. Most of this is driven through the standard HTTP methods. So we're talking about GET, POST, PUT, PATCH, and DELETE. Just in using the web, you're probably most familiar with GET and POST. Anytime you request a web page, you're performing a GET request. Anytime you're submitting a form, you're performing a POST. In the context of REST, we think of these methods as verbs. So for a GET, you're selecting resources, but never changing them. POST creates a resource based on the request. PUT replaces an existing resource, and PATCH modifies a portion of the resource. And DELETE deletes the resource. So you're not limited to updating single resources. You can also structure these methods in a way that requests can either update single resources, but also update collections of resources should you choose to implement your API that way. So when we talk about REST, we're talking about strictly following the requirements or guiding principles. So we adhere to these principles strictly. We ensure that the GET, PUT, and DELETE operations are idempotent, which mainly just means that they always behave in the same way. GET is read-only, but quite often we implement REST-like interfaces. REST-like API interfaces usually relax the statelessness requirement of REST. So we often carry the sessions and some other data across multiple requests if it benefits our API, but we keep the independence of the entities. So after a while, we learn to know when to follow REST rules and when to break them. If your application is primarily a CRUD, create, read, update, delete system, it's easier to stick to the guiding principles of REST. But if you have something new and novel, then it might not fit as well, and you need to stray from it to accommodate other features in your particular circumstances. So these are not always hard and fast rules. So if you have to stray from the REST principle, say from the statelessness objective, then you do so if you have to. But having a RESTful or REST-like API, say if you stick to the HTTP methods and keep your API endpoints consistently named, then that REST-like structure will make it easier to maintain in the long run. So what are some of the data formats that we deal with when we're implementing REST? Well, we have XML and JSON primarily. I'd say JSON has become the more de facto standard. It's more popular, at least as of this recording, but it's not going to be a competition, and you're not stuck with using JSON if you implement a REST API. So it's not a strict requirement. You can implement your API just fine in XML, and many systems often do. For many years, SOAP was the de facto standard for writing APIs, and XML was its language. But you're not limited to JSON or XML. You can use whatever format you define. But in this case, just don't mix formats. Pick one format and stick with it. And that concludes this video describing RESTful APIs. In this video, I'll describe practical applications and considerations for APIs in FSD. Well, what are some of the practical applications of FSD? What industries or what problems are solved using APIs? Well, we have APIs in monitoring tools to monitor the health of services, in sharing tools, in shopping, in search, in social media, and in DevOps. We have APIs that actually launch instances of services, containerization, all have their API interfaces. In some cases, the API is only internal, so the application is only available to the API creator themselves. So you have a website that uses an API to interact with a backend. But some of these APIs are opened up to third parties like search and social, that you can even monitor social media, post on social media using different client tools and not necessarily first-party clients because the APIs are open. We can have web services, microservices built in APIs where it's not client-server applications, but the APIs are server to server to server. So the servers themselves communicate using APIs. And the APIs don't have to differ that much between a client-server API that you'd see in typical FSD. What we work with often is the concept of routes. So when we're implementing API routing, such as using Python and Flask, what do the routes typically look like? Well, in a RESTful approach, we have something with the URL. So we have an HTTP or HTTPS : / and then we have the domain of our API, which might be something like api.example.com, or it might be example.com/API. And then you have some noun, something, or entity, which you can request a collection of where you just specify the entity, or you could have a numeric value, say thing/5, and it will return the thing with ID 5. We might have some entity called company, and company has a collection of employees. So you have employees belonging to a company. So if I request from the api.example.com, if I want to get the employee 3 from company 5, I might have something like /company/5/employee/3. So we have all these routes defined, some parts of it being fixed, like the entity name, and others like the ID, which are variable, that are parsed by the server. So we have custom paths and information. Now, one thing I would recommend is to keep the URLs clean of private data. So make sure sensitive data gets sent via HTTPS using the body of the request and not the command line. You'd never want to pass a password or some personally identifying information on the URL. You want to keep those to the body of the messages. Now, the other consideration for APIs in FSD I want to talk about is the responses and authentication. So with authentication, we're usually passing JWTs or JSON Web Tokens or sessions. So JWTs are tokens signed and encrypted, and they have a header, a payload, and a signature. Whereas the session IDs or session tokens, this information is kept on the server. So we authenticate a user, and then the server maintains the state of that user via a session. So this is not strictly REST by employing a session token approach. But in many practical cases, it's perfectly fine. So the session token that's generated to identify a login, and then that information is stored on the server either in memory or in a database, and is used to map back to the user's unique identifier within the server. So the session token is only passed back and forth. In the case of JWTs, you have some information about the session. You have some header, payload, and signature within the token itself that identifies the user. And then each of these tokens are passed back and forth with each request. And that concludes this video on practical applications of Python API for FSD. In this video, I'll share 4 choices of Python API frameworks, namely Django, Bottle, CherryPy, and Flask. Now, there are other frameworks, and there's nothing stopping you from rolling your own framework, though I'd recommend against writing an API framework from scratch. I'll share these 4 that I particularly like. So let's start by talking about Django. So this is the batteries included framework. So it does a lot of the work for you. It comes fully loaded with everything you need to build a server application. It has structured tools, so it emphasizes reusability of tools and pluggability of extending those tools. And it supports REST via the Django REST framework. So this adds REST support to Django. Now, the downside of Django is if you need something small without all the scaffolding it comes with, then it might be better to go with a more minimal framework like a micro framework. Django does a lot for you, but it can be opinionated about how it gets done, and at least more so than some other framework. Now, the opposite of that might be Bottle. So this is the super minimalist approach. We say it's a micro framework, but Flask is also a micro framework. It's a WSGI micro framework that's entirely contained within a single file module with no dependencies, except for the Python standard library. So these minimal dependencies are an advantage, but they can also be a disadvantage. If you don't need a minimal dependency approach for your API, then it might be safer to go with something a little larger like Django or something in between like Flask. It gives you many choices on how you extend Bottle without being too opinionated about it. Now, Cherry Pie is another one that's often overlooked. It's object-oriented, so it's good for the Python enthusiast. It comes with many built-in tools, it's extendable, just as any Python application is extendable, and it has nice test suites and profiling tools. And it provides a very Pythonic approach to code and application development. And it's fast and stable and easy to deploy. Now, sometimes Cherry Pie is not used as the framework for the API itself, but for its WSGI server used on top of things like Flask or Bottle in production environment, because it is fast and stable and easy to deploy. Now, in this course, I build my API examples using Flask. It's my go-to framework for writing APIs in Python, because I like the way it works, at least for me. It's also a micro-web framework as opposed to Django, so it's not the super minimalist approach Bottle provides. It does come with some tools and some capabilities, but it's very easily extendable, and it provides a very easy way to implement RESTful dispatching. And I'll present getting started with a Flask server application for an API in the video titled Python Flask API Scaffolding. And that concludes this video on Python API framework choices. In this video, I'll describe the concerns for API testing and talk about the benefits and tools for TDD for API development. So what are some of the testing concerns? Well, we have API endpoints that we need to test, and we need to test GET and POST requests and their different API endpoints. We need to test what happens when we pass invalid data or endpoints that aren't implemented. Does the server handle these cases gracefully? One thing I'll demonstrate in the video titled Handling Unexpected Errors is exactly that, making sure any error that occurs is handled and the error is returned in the correct format. In the case of Flask, the default handlers return HTML formatted errors, but we often need our errors in JSON format from our API server. That consistency is important and we need to test for it. We have to think about internal versus external tests. Running tests on local hosts, but are we accessing our APIs over a network? Do we need to test accessing them over the internet? Can we access the ports from outside of the local network where the server is running? We often need to be able to access the API from both internal and external networks. We can think of it testing in terms of white box or black box testing. We primarily think about testing our APIs by making the HTTP request. But libraries and classes and functions that make up our API might need to be tested directly, internally without going through the API. We call this white box testing. We often have to think about backwards compatibility and breaking changes. When you change the workings of your API functions, then you need to make sure you don't have any unintended consequences or introduce bugs or breaking changes to your API. If you're changing the way your API works, you may have issues with backwards compatibility. So with breaking changes, we often have to think about versioning. Often you need to introduce versions into your APIs when you introduce breaking changes. So you have a v1 as part of your API URL, and then a v2 and so on. But you'll need to test each of these independently. So if we'd like to automate our testing, we often use utilities like curl. It's the URL command line utility for making web requests. Or we can use a graphical user interface tool, like a browser interface tool such as Postman, that helps us manage our API and test it. And we could use tools like PyTest to write tests, especially for regression testing and test-driven development. So every API change can be retested across many different test cases in an automated way using PyTest. Now, the Postman utility gives a graphical user interface to write HTTP requests, which we can think of as an API development environment, like we think of an IDE for code. It helps us design APIs, and it helps us test and debug endpoint. You can group your tests in Postman into batches called collections, and you can even chain requests together and build requests based on the responses to previous requests. Of course, you can do all this with curl or PyTest, but Postman gives you a graphical user interface to do so. And if you prefer working that way, it's perfectly fine. And finally, we come to PyTest, which I think is the most important. This gives you detailed code testing and assertion introspection. And this is not just for APIs, obviously. You can use it to test any Python application. Often when we're testing APIs with PyTest, we're using the Python request library to make calls to our URL endpoints. It gives us an easy way of interpreting the results and parsing things like JSON formatted responses that the server returns. Now, this is universal within Python, and if we're building a Python API server, it often makes sense to test it with the same code, the same language that we're implementing our server in. But it's not a strict requirement, but it often makes things easier. And that concludes this video on test-driven API development. In this video, I'll demonstrate how to configure a simple API endpoint in a Python Flask application. I'll start with the basic scaffolding to get up and running, so I'll cover all of the files I use in a simple Flask application server that works with any number of high-level tools or IDEs that you might end up using based on your own personal preferences. So the requirements for this video are Python 3, the curl command line utility, and a web browser. In this case, I'll use Firefox. So I'll start inside this application folder in documents/dev/scaffolding. I have some files in this directory that are needed for this blueprint of a Flask application, but before we do so, we need to install a Flask environment. So I'm going to use Python 3 -m venv and env Flask API. So I'm going to create a virtual environment using env Flask API. So that's going to be the name of our environment. Now I can run source of env Flask API /bin/activate. So now that we've created a virtual environment and enabled it using source, we have the environment in parentheses prepended to our prompt. So that shows us that we're working within this particular virtual environment. So now we can install packages and dependencies inside of this environment only. Now for that, we need to create a requirements.txt. So I have one created for this blueprint, and this requirements.txt in the current folder has 3 dependencies. We have Flask, and then we have greater than equal 1.1.1. So this is the version, the minimum version that we require for Flask. So as of this recording, this is the current version. So we want this version or something newer. I install Flask Restful. Now this is not a strict requirement for a Python Flask application, and it's often used for RESTful or REST-like applications. But even if you're not using a RESTful application, the Flask Restful library gives us a nice structure for assigning our paths or endpoints to particular objects or entities. So I use Flask Restful greater than or equal to 0.3.7. And then I have Green Unicorn, which is often pronounced as G Unicorn or Gunicorn, depending on who you talk to. So this is an HTTP server for Flask using the Python Web Server Gateway Interface, or WSGI or WSGI. So I have the version greater than or equal 19.9.0. So I'll close the requirements.txt, and I'll go back to the terminal window, and now I'll run pip install -r requirements.txt. And this will install all of these libraries inside of our virtual environment, so we can use them in our Flask application. So now that it's been installed, I'll clear the window so we can start with a fresh terminal window. And now we'll go through all of the files in this folder. So I'll take you through all the files using Emacs, but you can use whatever text editor or IDE you'd like to actually go through the files. It doesn't really matter. The files and the scaffolding is platform agnostic. So we've seen requirements.txt. Now I'll open the next file, config.py. So any services you're using that require configurations that are part of your application, you usually put them in here in your config.py file. In this case, the only thing I'm setting is debug equal to true. So we'll get all the debug information printed to standard out when we run the code. So I'll close this file. And now we'll look at run.py. So this is the Python file to run our application. And in this run.py from API, so API is a local folder that has a file app.py that we import. So from API, import app. Then I create an application instance. So our server application instance called application equals app.create_app. So it calls this function, which returns a Flask application. And then if the module name is equal to main or _main, we call application.run, and we run it on the current host at 0.0.0.0. So it's not bound to any particular IP address. Although we may launch this directly when we're testing our application, most often we'll run it through gunicorn to run the application. So this code is just there for the case we'd like to run this directly. Now I'll go into serve.sh, which is a bash shell command that we'd like to run to launch our application. In this case, it invokes gunicorn, and it calls --bind on 0.0.0.0:5000. So it's going to bind to the local address on port 5000. It's going to set the --access log file to the hyphen. So a single hyphen means just log it to the standard output, so which is really good for debugging. And then run:\application. So run comes from our run.py file, and application comes from the object in that file that contains a Python application. So I'll close this serve.sh, and now I'll go into the API folder. So there are three important files in this folder as part of our scaffolding. The app.py, which creates our Flask application, the entity.py, which maps an endpoint to a particular Python object or resource, and the extensions.py, a file I use to add any extensions to my Flask application. So for connecting to a caching service or a log server or a database server or a NoSQL server or any other extensions that we add to our application, I define them in extensions.py. So let's start with extensions.py. It's quite a simple one. In this case, from Flask_Restful, I import API with a capital A. So all it does is import the API. If there are any other additional configuration options I could set, I would define them here. I just want to import the API. And now in the app.py file, this is the important part that actually creates our Flask application instance. So from Flask, I import Flask. From api.extensions, I import API. And then from api.entity, I import an object called EntityView, which is a Flask Restful resource that we can use to map to an endpoint. And now in the function I define as create app, I have app equal to Flask with _name, built-in variable, comma, instance relative config equals true, which makes it easier to find our config file. And then I set app.config.from_object to the string config. So this will find the config file that we've created, config.py, in our root folder of the project, and it will load that configuration. In this case, it will set debug equal to true. And now we need to associate our Flask app with the Flask Restful API. So I create a variable called API, all in lowercase, equals API with the uppercase A, and then I pass app to it. So this will let us assign features from Flask to our Flask Restful API. And the important one are the endpoints. In this case, we're going to define a single endpoint. So I set api.add_resource with EntityView mapped to the /. So the root folder, or the root endpoint of the server will be mapped to EntityView. and then I return app. Now there's one more file, the entity.py, which defines the entity view. So from Flask Restful, I import resource, and from datetime, I import datetime, because I'm going to return the current date and time. So I define a class called entityView, which is a type of resource. So in parentheses, I specify resource, which I get from Flask Restful, and then I define the get function. So this will map it to the get request that comes in from an HTTP request. So we're defining the behavior of a get request, what gets returned from our application when somebody calls get on our endpoint. So I define get, which is a member of entityView. So in parentheses, I specify self, and then the body of this function just returns an object, so an open brace with time, colon, and then an F string with datetime.today returned. And then I close my brace, comma, 200. So 200 is the HTTP return code, meaning successful. And this Python object, this dictionary that we return, gets converted into a JSON object. So it will return a JSON string. So that gets handled by Flask Restful for us under the hood. So that takes care of all of our scaffolding. Now I can go back to the terminal window, and now I can run /serve.sh. And this will run the application. So once it's running, I'll tab over to Firefox and I'll load localhost 5000. So it takes a moment to spin up the server, run our code, and return the result. So we get a JSON of time with the current date and time. And if I look at the headers or the raw data, I can see the raw string that's returned by our API endpoint. And I can look at the headers to see the response headers from the application. So it tells me that the server is gunicorn, and it gives me the content type, in this case, application/JSON. Now, if I open another terminal window and I run curl and I specify http:// of localhost 5000, this is going to make a request from the command line to our API endpoint. And that returns the same string calling our function. So this provides us with another way of testing our endpoints from the terminal window, from a command line. So with this scaffolding, we set the stage to build the structure of our API server. And that concludes this demonstration on how to configure a simple API endpoint in a Python Flask application. In this video, I'll demonstrate how to process data received via GET and POST requests, as well as reading HTTP headers. So I'm starting here in this file app.py, similar to what I described in the video titled Python Flask API Scaffolding. So I'm using the same scaffolding, but the important change for this video is on line 14, where I map the parse HTTP data view to the root endpoint, so just the /. So I'll close app.py, and I'll open parse HTTP data.py. So this contains the demonstration code for this video. So on line 1, from Flask, I import request, and from Flask Restful, I import resource, because our parse HTTP data view is a Flask Restful resource. So on line 4, I have class parse HTTP data view of resource, and in the body of this class, I have two functions, two methods defined, get and post. So these functions correspond to the get and post requests via HTTP. So let's start with the get on line 6. So I def get with self, so it's a member function of parse HTTP data view. So in the body of get, I print an empty print statement on line 7, just to put some space between this and the previous log line. And then I print in, surrounded with asterisks, get request, so it's a literal string. Then I print the request args. So this is the query string in the get request. So I specify request.args. So this is everything after the question mark in the URL. If I want to access a single value out of the get request, so a single named value, on line 10, I print the request args of hello. So if there's a variable called hello, it will print its value. And I access it with request.args.get, and I specify the string hello. Then I put in an empty print statement. Then on line 12, I print the string headers surrounded in asterisks. And then I print headers, and I put an empty line after the headers because there'll be multiple headers and I just specify request.headers. Then I print the user agent, one of the variables passed as a header that we received by the server. So our application can access that with request.headers.get of user-agent. And then finally, the message I return from the server is return, and I have this Python dictionary with message and get OK, and the status in this case is 200, so it's a successful message response. Now in the post method, I access the variables in the post request, and I'm assuming that these are sent via JSON. So on line 19 in the body, I print an empty print statement, I print post request surrounded in asterisks, and then I get the JSON data. So JSON_data equals request.getJSON. And now I can access the data with print post data, so a literal string with JSON in parentheses, so I know what I'm accessing, and then followed by the JSON data variable to print it as is. Now in this case, it will be a Python dictionary, so I can access individual elements from that data. And in this case, one of the named variables inside of the JSON data is email. So I print post email, so I access that with JSON_data.get, and I specify the email string. And in this case, I return a message with post OK as its value and a response code of 200 to indicate that it was returned successfully. So now I'll switch over to a terminal window. And the terminal window I'm going to use is in the document/dev/data parsing folder. And I've already loaded my Python environment for this project. And in the current directory, I have a file called serve.sh, which will launch the server. So this was demonstrated in the video titled Python Flask API Scaffolding. So I do a / of serve.sh. It will use gunicorn to run the application. And now it's waiting for a request. Now I could do a request by loading the browser, but another way we can do that is using curl. So I'll switch to a different terminal window in the tests folder where I have two files, get.sh and post.sh. So I'll use cat on the command line with get.sh to see the contents of it. And all this contains is curl of HTTP of localhost 5000, so it'll call the local server with a question mark with hello equals world, ampersand. Now I have a backslash in to escape the ampersand because it's a special character in Bash, but it'll just be essentially hello equals world, ampersand name equals value. That's what the server will receive. Now I'll do a /get.sh, and it returns the JSON of message and get OK. Now before I go over to the other terminal window where the server is running and have a look at the output, I'm going to do the same thing with the post.sh file I have in the local folder. So I'll do cat of post.sh to see the contents. And in this case, it's a longer curl statement because we have to prepare the data we want posted to the server. So in this case, I have curl with -X, and I specify post because we want to submit the data as a post request. Then _header, and I indicate that the content type is of type application/JSON. And then _data. Now, as a string, try that again. Now, as a string, I represent this JSON data. So I have a single quote and an open brace, and then in double quotes, I have email, : then in email, I have steve@example.org, number, : 1000, and then I close the brace, and I close the string with the single quote. And then part of that is http : localhost 5000. So this will be sent as a post request, and my post function should deal with it. So post.sh, and you'll see the response is post OK. Now I've called each of the functions successfully. Now I can switch back over to the other terminal window where the server is running. So you'll see in the output, we have get request. So the request.args variable is an immutable multi-dict with hello and world and name and value. So if I call the request args requesting the hello variable, I get the value world. So I can access the individual elements from the name value pairs. The headers, I received 3 headers from the curl request. So I have the host, which is localhost 5000, the user agent, in this case curl /7.58.0, so curl / the version number, and accept So accept are the content types that it expects to receive, which it can handle any. And now I do access the args user agent directly, and that returns the same information, so the curl/version number. And finally, the server, every time I make a request, it outputs some details about the request. So the responder, the date and time, the request itself, get with the /? hello equals world, ampersand name equals value, the HTTP version, the response code, the length, and the user agent at the end. Now let's look at the post request. So the JSON gets parsed by the Flask request, and the JSON data variable gives us a dictionary with the email and the actual email, email, steve@example.org, comma, number, 1000. The post's email value that I get returns steve@example.org, and then I get the request itself. So it's a post. Now, it only shows the URL, which in this case is the /, because the data is sent in the body of the message. Now I'll make one more request, and this is from the web browser. So if I do a localhost :5000 / and I do hello equals world, it'll take a moment to connect, and then returns the message with get OK. Now if I look in the output and I go directly to the header section, the host is localhost :5000, the user agent is Mozilla /5.0, and all this extra information about the browser. So in this case, instead of curl, I get it requested from Mozilla Firefox. And then it accepts different encodings, it specifies different headers. So depending on the user agent that's making the request, the server will receive different headers. And that concludes this demonstration on how to process HTTP data. In this video, I'll demonstrate how to parse and return JSON payloads from a Python Flask API server. So I'm starting in this file with the app.py file open, which I described in the video titled Python Flask API Scaffolding. The important changes in this video are on line 3, where I import the resource. So from api.temperature, I import temperature view. The example endpoint I'm going to demonstrate in this API is a temperature conversion utility. So it's going to take a temperature in degrees Fahrenheit and convert it to Celsius, or a temperature in Celsius and return its result in Fahrenheit. Then on line 14, I have api.addResource of the temperature view, and I map it to the endpoint temperature. Now I'll close this file and open the temperature.py file. So in this file, I define the class temperature view as type resource. So in line 1, from Flask I import request, from Flask Restful I import resource, and I import sys. So in line 8, I define a function post. So this is the handler that responds to post requests on our server. So when something is posted to the temperature endpoint, it's going to be posted in JSON format. So to parse JSON, I use request, which comes from the Flask library. So on line 9, I have data equals request.getJSON. So this parses the JSON and converts it into a Python dictionary, which I store in data. So we can access data like any Python dictionary. Then on line 11, I start a try block in case there's a problem with the conversion. So if the temperature is passed in a non-numeric format, then there could be an exception, a value error, that we need to catch and respond to appropriately. So on line 12, I have temperature equals float of data.get temperature. So when we're accessing dictionaries in Python, we can call the .get, or we can access it like an array element, like on line 13, unit equals data, and then in square brackets, I put the string unit to access that element. And then on line 14, I define the result. So to return a JSON payload, we just return a dictionary. Our dictionary result will be converted into JSON by Flask Restful and it'll be returned as a JSON string to our client. So on line 14, I define a result as an empty dictionary. So we're going to build up this result dictionary and return it as our result. Now the unit, it's expecting F for Fahrenheit or C for Celsius. So on line 16, if unit is equal to F, Then the resulting temperature, so result at index temperature, so the temperature string, so we're adding this to our dictionary, is equal to temperature minus 32 in parentheses, so we have to subtract 32 first, then divide by 9 and multiply by 5. Otherwise, on line 19, we have our else block. So in this case, we've received a temperature as Celsius, and we need to convert it to Fahrenheit. So result of temperature equals temperature multiplied by 9 divided by 5, and then at the end we add 32. And this gives us a result in Fahrenheit. So we set result unit equals F. And then on line 23, I return result, which is a dictionary that gets converted into a JSON string by our resource, by our Flask Restful resource, comma, the HTTP status code. In this case, I return 200, which means success. And then on line 25, I have an except to catch the exception if there's one thrown. So I loop over the sys.exe info so that I can print all of the lines describing the exception. So for E in sys.exe info, print E. So this will be printed on the server, either printed to the standard out, which is how I've defined it in this case, or it could print it to a log file. Then on line 25, I extract the return message equal to the string of sys.exe info at index 0. So it's going to take the first item and return that as part of the message body that's returned to our client. So on line 30, I return and I create a dictionary inline using the brace notation, and then I define an error, true, and message is equal to that message that we've just sent. And the status code in this case is going to be a 400. Now, an HTTP status code is an error defining a bad request. Since we couldn't parse the request, we assume it to be bad, and we return that information to the client to say that it's a bad request. So now I'll switch over to the terminal window, and inside of this document/dev/json payloads, I'm going to run the serve function. So this serve shell script, which uses gunicorn to run my code. So once it starts, I can switch over to another terminal window, and I'm in that same folder, but in a tests subfolder. So if I look in this folder, there's 3 tests. So I'm going to output the contents of the first test, test1.sh, and we'll look at what's being sent to the server. So we have to send a JSON payload. So I'm doing a curl of type post, so -x, capital X of post. The header has a content type of application/JSON, and the data has a string defined as a JSON string with temperature set to -40 and the unit equals C. And we call the http://localhost:5000/temperature. So if I do test1.sh, it returns a temperature of -40 in Fahrenheit. This is a tricky one because the Fahrenheit scale and the Celsius scale cross at -40. So -40 Celsius is the same thing as -40 Fahrenheit. Now I'll output the contents of test2.sh. So in this case, it's the same request, but there's a temperature of 100 and the unit is Fahrenheit. So 100 degrees Fahrenheit, we'll see how that converts into Celsius. If I run test2, it gives me a temperature of 37.7 repeating and a unit of C. So that completed successfully. Now let's look at the contents of test3. It's the same as the other two, but temperature, I pass a string instead of a number, and the string is the literal string, not a number. So if I run test3, we should be able to see what the error is returned. And in this case, I get an error returned as true, and a message shows class value error. And if I switch over to where the server is running, so the terminal window where the server is running, I can see the requests being posted, but then I see class value error, and it says could not convert string to float, not a number. So it shows the error string. Now, if we wanted to be a bit more accurate with this, we could probably put the entire contents of the error of the exception into the return string to show to the client. And that concludes this demonstration of parsing and returning JSON payloads. In this video, I'll demonstrate how to implement default error handlers for a Python Flask API to return JSON formatted errors instead of HTML. So I'll start in app.py, which I described in the video titled Parse and Return JSON Payloads. So I'm using the same example with the temperature conversion endpoint, but with a few changes. So I'll start on line 5. I have from worksig.exceptions. So worksig is the underlying server library that runs a Flask application. And from it, I import HTTP exception and default exceptions. So it already defines a number of default exceptions which we're going to override. And then in the create app method, on line 11, I have a comment default all errors to JSON errors instead of HTML. So what the code is going to do, I start by looping for code in default exceptions. So it's going to go through all of the default exceptions, all of the status codes, and I'm going to call app.register error handler. I'm going to give it the code, so this will be a numeric value, and then a JSON error. So this JSON error method is defined below, and I'll describe it in a moment. And then on line 14, outside of the loop, I have app.register error handler, and I pass exception, so all exceptions, if they're uncaught, will be handled by the JSON error method. So now I'll scroll down to line 25, where I have def JSON error, and it takes a single argument, an error argument. So this is a type of exception, and I check to see if is instance of error is an HTTP exception. If it is, then I set the status code equal to error code. So I'm going to use the error that's the HTTP exception. If it's any other exception, then I'm going to just describe it as an internal server error, which is a code 500. So I have else status code equals 500. And then I return on line 31 JSONify, so it's going to turn the error message, this dict, into a JSON string, and it's going to return it with the status code. So I have error, and then I convert the error to a string, comma, status code. So this will return the correct HTTP status code and the message formatted in JSON to the client, whoever's calling our API. So now I'm going to switch over to a terminal window. In one window, I have the server already running. So I'm serving what I've just described. And then in another terminal window, I'm inside of the tests folder for this project. I'm going to do an ls. I have two shell scripts, badrequest.sh and test1.sh, that are going to invoke curl on the endpoints. So if I do a cat of test1.sh, it's just going to do a regular curl, passing a temperature of -40 and a unit of C, so that the server can convert it from temperatures in degrees Celsius to Fahrenheit. So if I do /test1.sh, it will run it here, and it returns a temperature of -40 in degrees Fahrenheit, which is the correct conversion. Now, if we look at the contents of bad requests, I'll do a cat of badrequest.sh, and it's the same request except for the endpoint. So if we look at the URL, it's http:// of localhost 5000, but then the endpoint is /not found. So this is an endpoint that hasn't been implemented, so we don't handle it on the server. So this will create an error. So if I run bad request to make the request to the server, I get a JSON formatted response. So we still get the open and close brace, and inside of it, in correct JSON, we have error, colon, and then we have the string 404 not found and a description of the error. Now, if I go back to the code, and this time I'm going to go into app.py, and I'm going to comment out where we've registered the error handler. So I'm going to remove that. So it's going to rely on the default one, which will return it in HTML. So now if I restart the server and rerun the bad request, in the output, I have an HTML formatted output. Now, this might be fine if we're accessing a web page and expecting a web server to return to a web browser, but if we have a program that's making an API request, we want it in the JSON format that we can parse and not the HTML format. So that's why it's important to override these error handlers so that we can return them in the method that we want. And that concludes this video on handling unaccepted errors in a Python Flask API. In this video, I'll demonstrate how to configure logging for a Python Flask API server. Now I'm using the same example code from the video titled Parse and Return JSON Payloads, with a few changes to add logging. Now there are different ways to configure logging, and one of the most useful approaches, one that's often overlooked, is to use the syslog. It's a standard logging method and format, and it also scales well, and it operates well with enterprise logging tools. So I'm in my config.py file for the project, and I'm going to start on line 1 with an import logging. So this is something we get directly from Python, and then from logging.config, I import dictconfig, so we can configure our logging with a dictionary. I have the debug equals true directive from before, and then I have my dictconfig on line 6, and then it takes a dictionary, I give it version 1, and then I define some formatters. So this is going to be the output format, so what's going to be printed in the syslog. So formatter's default, I set the format to %, and in parentheses module s. So this is a defined string format that gets substituted by whatever module that it's called from. So if we do logging.debug from a particular module, it will substitute the name in. We have the level name, so what log level, whether it's info, debug, error, etc. The path name to the file, the function name, the line number, and then the message that's printed. So if there's a problem or if there's a log message we need to know about, we know exactly where it's called from down to the path, the function, and the line number. Now I want to define the handler for the WSGI syslog. So this is going to be built into our server so we can log messages to our log file, which will be in var log syslog on our system. So the class we specify for the handler is logging.handlers.sysloghandler, which is something built right into Python. Address is dev/dev/log. The facility is local 7. So this refers to the machine, and it's defined as one of the built-in descriptors in the syslog RFCs. And then the formatter we set to default, which we defined above. Then on line 17, I have work null log. So this is for the worksite underlying library to Flask. Now, what happens is sometimes we have double log messages coming from different parts of our system. And I want to redirect the worksite log handler to the null handler, which is a do-nothing handler. So I set the class to logging.nullhandler. So I set root, which is the top level logger. So I set the level to debug. The handlers is WSGI syslog and propagate true. So I want to propagate the messages. Then for worksite, I want to set the level only to error, the handlers to null log, and then propagate false. So this helps the logging systems work well together, and we avoid duplicate logging events. Now the other change I'm going to make in this project is in the API folder, which I'll navigate to and open the temperature.py file. So this is the same from the video parse and return JSON payloads, except inside the post method, inside the resource, inside our temperature view, is on line 10, I have logging.debug. So this is how I print a logging message. And on line 4, I import logging so that we can call this. I have an f string defined with hello debug, and then the date time today. So it's going to have hello debug followed by a date timestamp. Then I get the request, so data equals request.getJSON. And then I'm going to log this information, so whatever JSON was passed. So I call logging.debug of data to see what was parsed. Now I'm going to switch over to a terminal window, and I'm going to start the server. So I'm going to run serve.sh, which launches the server, and I'm going to go to another terminal window, an empty terminal window, and I'm going to run tail-f, which means follow /var/log/syslog. And this is where it's going to be written to. So we're going to follow this file. Now, in my third terminal window, I'm in my tests folder, where it has badrequest.sh and test1.sh. So what I'd like to do is run test1.sh, which will use curl to call our temperature endpoint. And I get a response after the conversion, so I get temperature -40 and unit F. So it responded successfully. Now if I look inside the log, I get two debug messages, the ones that we created when we called logging.debug. So the first one, it has the date, the day, the time, VM1, the server, the temperature, so that's the module, the log level, the path and file, so all of the whole entire path to temperature.py. It's in the post method on line 10. And we get hello debug and the current date timestamp. And then the next one is 2 lines down on line 12, and we get the request information, the temperature, -40, and the unit C. And this is all written to var log syslog. Now, there are different ways we can configure logging. We can use files and different subsystems. This is just one example of one way we can handle logging using the syslog. And that concludes this demonstration of logging for a Python API. In this video, I'll demonstrate how to use PyTest to run automated tests on API endpoints. In other videos I've done, such as the one titled Parse and Return JSON Payloads, I used the command line utility curl inside of shell scripts to test API endpoints. This works okay in limited demonstrations, but for more comprehensive tests, it's better to turn to a systematic approach such as PyTest. So to use PyTest and to make API requests, so we're making HTTP requests, I'm using the PyTest library and the requests library. So I need to add those to my requirements.txt and do an install on it so that we have those libraries. Now I've already done the install for this demonstration, and in requirements.txt, I have on line 6 PyTest greater than or equal to 5.0.1, so that's the latest version as of this recording, and the requests library greater than or equal to 2.22.0. So it's using the most recent versions of these, and if there's an updated one, because I've used greater than or equal, when I run pip install, it will get the latest version. So now I'll close requirements.txt, and I'll go into my tests folder, where I have a test1.sh, which was used in a previous video, and the test_temperature.py, because I'm going to test the temperature endpoint. Now, PyTest looks in the current directory that it's run in and its subdirectories for files with the prefix test_ or the suffix _test with the .py extension, obviously. Then in those files, it will run functions with the test prefix. So in this file, say for example on line 5, I define a function with test_, so test -40. Now I'll get into this in a moment. Now I have two terminal windows open already. One is running the server, so I'm already serving the server, so I need to make sure it's running. And in the other one, I'm in the tests folder inside of this project, which if I do an ls, you can see there's the test1.sh and test_temperature.py that I have open in my editor. Now in previous videos, I've just used the test shell scripts. Try it again. I've just used these test shell scripts with curl in them. So curl with posts, and it specifies a header as application JSON, and the data provides a temperature and a unit to convert from Celsius to Fahrenheit or Fahrenheit to Celsius. And if I run it, I do a test1.sh, I see the result. It doesn't check that the response code is correct. It doesn't check that the conversions were correct. If I make a change to the server, if I have to come to the command line and retype every shell script I've made and look at the responses and verify them manually, it's going to be very time consuming. And it's also written in the bash shell language. And if I wanted to do something with the results, I'd have to parse them and look at the results. So the reason I've gone with PyTest is to take a more systematic approach. So I'll go back to the Emacs window, my editor, where I have the test file open, testtemperature.py. So the requests library lets me make requests to URLs, either doing GET requests or POST requests. And on line 3, I set the URL to the endpoint I'm going to test. So URL equals http://localhost:5000, where the server is running, /temperature, the endpoint I'd like to test. Now I'm going to go through the 3 functions that I've created, and all of these are prefixed with test, because PyTest will look in the file and run all of the functions that have the tests. So the first one, def test _-40. So this will make a request to convert a temperature that's -40 in degrees Celsius, and it will check the response. So data is the dictionary with temperature set to -40.0 and the unit C for Celsius. Then on line 7, I have res equals requests.post. I specify the URL equal to the URL variable, and then there's a parameter JSON, which I set the data. So this is going to take a Python dictionary, convert it to JSON, and make a post request with a content type of JSON. And then on line 9, I check the result. So I do an assert. Assert provides a way of testing values. It's a keyword so that we can say assert that res.statuscode equals the $=200. So if the status code is anything other than 200, the HTTP status code for success, PyTest will see that as an error and the test will fail. Then on line 10, I set the content, so the results equal res.json, because the response is in JSON format. And then I assert that the content indexed at temperature is equal to -40. So that's the point on the scale, on the temperature scale, that both Celsius and Fahrenheit match. And I do the same thing for the unit. So on line 12, I assert that the content unit is equal to F. So to make sure that the server returns the Fahrenheit and not the Celsius. So the next function is test_nan. So I set data equal to the dictionary with temperature set to the string, not a number. So it literally says not a number. And then I set the unit to C. And then I make the request, so res equals request.post with the URL equal to the URL variable and JSON equal to the data. And then when I get the response, I want to assert that res.statuscode is equal to 400, which means bad request. Now this is what we expect the server to return if we pass an invalid temperature, so we pass a string instead of a numeric value. Then the third function and final function that we're going to test is called test_100f. So this will take data equal to the dictionary with temperature set to 100 and the unit Fahrenheit. So let's see how it converts 100 Fahrenheit into Celsius. I set res equal to request.post of URL equal to URL and JSON equal to data. I assert that the res.statuscode is equal to 200 because it should have no trouble converting this value. And then I get the content, so content equals res.json, and then I can check the temperature value. Now I know that converting from 100 Fahrenheit to Celsius is 37.7 repeating. So I want a value between 37.7 and 37.8. Now if I try to match an exact value, I'll probably run into problems because I don't know how many digits that the server is going to return. So I assert that the content temperature is greater than 37.7, and, so I'm using some Boolean logic, the AND operator, content temperature is less than 37.8. And I assert that the content unit is equal to C, because we're converting from Fahrenheit to Celsius. Now I'll go back to the terminal window in the tests folder, and I'll just type in PyTest. And this will find the test temperature file and run the tests. So it shows me the platform, Linux, Python 3.6.8, PyTests 5.0.1, Py, Pluggy, the dependencies that it runs with. And then the root dir is the home Steve documents dev testing tests folder that it's looking in. And it finds 3 items to test, the 3 functions inside of testtemperature.py. And it shows me that it's passed 100%, so 3 out of 3. And at the end, it shows 3 passed tests in 0.10 seconds. Now, if I go back just quickly now and make a change, so let's go back to the test_nan, and I change the status code equal to 400 to 200. So I know that this is going to fail, and so we can run PyTest again to see what happens if one of the tests fails. And in this case, the results, it says the failure shows where the failure is in test_nan. It tells me that 1 test failed and 2 passed. And it says that there's an assertion error on line 18. It also shows me what assert happened. So it's asserting that 400 is equal to 200. So the status code is 400, and it shows me exactly what happened, why the test failed. And I can go in and either fix the server if it's a server problem, or if it's a problem in the test and I know that, wait a minute, it really is supposed to be 400. I need to go in and change the code to 400 so that it passes successfully. So it can either be a problem in your test case or in the server. And if it's a problem in your server, then you go in the server and make the change and rerun the test. So it's good to, any changes you make in your API or in your server, in any logic, you should make sure that all logic paths are tested and that any change that it doesn't have any side effects. So maybe you're fixing one thing, but it breaks something else. So unintended consequences are one of the reasons we run tests like this. And after I change the code back, all of my test cases, the 3 test cases, passed again. And that concludes this video on running tests with PyTest against an API. In this exercise, you'll create a Python Flask application, implement get and post handlers for an endpoint, run the application server, and test the API endpoints that you've implemented. Now you can pause the video and perform the exercise, and when you've completed it, come back to the video to see what I did. Now here's how I carried out the exercise. So I've created a Python Flask application. So I have all of the Python Flask API scaffolding in place, as I covered in the video by that title. So I have a config file with the configuration settings for logging. I have a requirements.txt with the dependencies, a run.py, a serve.py, and then I have it implemented in the API and tests folder. And as well, I have the env Flask API folder with the current environment. So the next step in the exercise is to implement the get and post handlers for an endpoint. So in the API folder, I have an app.py file that creates the Flask instance. So if I go into this file, and on line 20, I have api.addResource distance view. So this is the resource that implements the get and post endpoints, and I map that to the distance path in the URL. So now if I close this and go to the distance.py file in the same directory, I have my distance view implemented. So on line 8, I create a method called get. So what this will do on a get request, it will return the conversion from miles to kilometers, and the post will take a distance and a unit, and it will convert the distance from whatever units you specify, either kilometers or miles, and convert it to the other one. So if you pass in a distance of 1 mile, it will return 1.6.09344 kilometers. And I've implemented a get method on line 8, so def get, and this returns the JSON. So it returns a JSON because this is a Flask Restful resource. It converts the dictionary I have on this line to a JSON string. So it has the key mi, the string mi, which maps to 1, and the string km, which maps to 1.609344. So the conversion from 1 mile to kilometers, and a status code of 200 for success. So it's a very simple get implementation to return the conversion. And now the post request, it starts with a try block on line 12. Then I get the data, so data equals request.getJSON. A distance is equal to the float conversion of data.get of the distance. Unit equals data of unit. And the result, I create an empty dictionary, which I'm going to populate. So on line 18, I have if unit equals mi, the shorthand for miles, I convert the distance passed in to kilometers. So result distance equals the distance times 1.609344, the conversion to kilometers, and the result unit equals km. Else, the result distance is equal to distance times 0.6213712, the conversion from kilometers to miles. and then the result unit is equal to mi, and then I return the result and the status code 200. Now, if there's an exception, so this will happen quite often if there's a distance that is not a number, not a numeric value, and can't be converted to float, which will result in a value error exception, I create a message for e in sys.exeinfo, so I loop over each line in the exception, and then I append that to the message with a new line character, and then I log this with logging.debug of message, and I return error true with a status code of 400, bad request. So now we can carry out the next step to run the application server. So if I go to my terminal window, one of my terminal windows, so I have two open, I go to one, and I'm inside this API exercise folder, and there's a serve.sh file. So now I'll just run /serve.sh. So this launches my application server. Now I'm going to go to the other terminal window. Now I'm already in the current env Flask API environment, and I'm in the tests folder where there's a test_distance.py file. So this implements my unit tests. So let's have a look at this file inside of my editor, inside of Emacs. So I'll go up and into the tests folder and open up test_distance.py. So this imports requests, and it sets to the URL to be equal to the http://localhost:5000 of the distance endpoint. So it'll make requests to this endpoint, which is now running. Now I've implemented 4 tests. I test when I pass 10 kilometers in to make sure I get a correct response in terms of a conversion to miles. I test what happens when I pass not a number or nan in. So I set the distance to the string not a number, and I expect in this case a return code of 400. So on line 18, I assert that the status code is equal to 400. I test that conversion from 40 miles to kilometers converts to the correct value, and I assert in that case, as in on line 24, that the status code is 200. I read the content using res.json from the requests result, and I check that the distance is equal to 64.37376, the conversion from 40 miles to kilometers, and that the unit returns as km. And then the final test that I implement is to test the get. So I make a get request. So on line 30, I do res equals requests.get of the URL. And then I check that the status code is 200. And then the content of mi contains 1.0, and the content of km is equal to 1.609344, as I defined when I implemented that endpoint. Now I'll go to my terminal window. In that folder, the tests folder, I'll run pytest, which will look for any file that begins with test underscore, which my test distance does, and look at the test functions inside of that file. So here it carries out the 4 tests, and the 4 of them did pass successfully. So we were able to test the API endpoints, and that was the last step in the exercise. And that concludes this exercise on implementing a Python API server.
In this video, I'll identify how secure programming applies to full-stack developers. A full-stack developer, as some of you may already know, is a developer which has skills in both front-end and back-end development. This allows the developer to work across the whole stack of an application, from the back-end APIs, database calls, and routing to the front-end user interface, JavaScript, and HTML code. Security is crucial to full-stack web apps, as they run on the internet, where malicious users and programs can attempt to harm or modify the apps in an undesirable way. User and session data needs to be stored and secured in a way such that users of a web app are protected. Common security measures used in most web apps include HTTPS, XSS, and logging. HTTPS, or Hypertext Transfer Protocol Secure, is an extension of the HTTP protocol used for the internet for transfer of data. Information is encrypted using Transport Layer Security, which is TLS, or Secure Socket Layer SSL. HTTPS uses signed certificates from a certificate authority in order to encrypt communications from client to server and prevent man-in-the-middle attacks. XSS or cross-site scripting is a potential issue with unsecured web apps where an attacker can inject malicious client-side scripts and send them to unsuspecting users. XSS works particularly well because it fools the application into thinking that the script is trusted and it doesn't reject it. Common places where XSS attacks can occur is forums or in comments. One way to fix cross-site scripting attacks is to sanitize data, which means that input data should be checked for malicious code before displaying it on the web browser. Logging is crucial for secure web apps. By keeping track of users, sessions, and data sent from a web app, it becomes easier to see where and when a security vulnerability was breached. Secure programming involves building web apps in a well-thought-out and architecturally strong way. A tech blueprint is a good first start. It shows permissions for packages, libraries, and other pieces of software which will be included in the web app. By analyzing permissions before including packages in the architecture plan, it becomes easier to pick and choose which packages and libraries are most secure. By using open source software and making an app open source, it becomes easier to expose and fix bugs as a greater number of developers are using the code at any given time. In order to do this, a method or software platform such as GitHub must be put in place to organize bug reports and fixes. The OWASP Top 10 list displays a list of the top 10 yearly threats to web app security. These include injection, XSS attacks, insufficient logging, using packages with vulnerabilities, and broken access control. It is useful to use a checklist when going over a web app's architecture. HSTS or HTTP strict transport security forces browsers to use HTTPS to connect and send data which is secured using either TLS or SSL. HSTS is defined in a response header and specifies the time frame for which the client browser must use HTTPS. HSTS does not redirect HTTP requests to HTTPS and instead denies them. This is a potential problem for users with browsers that do not support TLS, as they will be denied connection requests. As I mentioned, XSS or cross-site scripting allows an attacker to place malicious scripts into the client-side code. There are several techniques to prevent XSS attacks. Some security measures include not putting untrusted data in the script, comment or div tags or documents, and there's also an x-xss-protection header which can be set by websites and which is supported by modern browsers. If a site sets this header, client browsers will block malicious scripts and not sanitize them. Clickjacking is the process of getting a user to unintentionally click something that doesn't do what they expect. An example of this could be a malicious email being sent from a fake email address displaying a workplace memo. If an employee clicks the link to view the memo in the malicious email, they may actually be clicking an invisible page which will download a malicious package onto their computer. A content security policy prevents code injection, clickjacking, and XSS attacks by defining a set of trusted or approved data sources for browsers to load on a website. Many websites cache sensitive user data such as URL histories, cookies, and HTTP headers. This is done in order to make a user's experience using a web app more streamlined and enjoyable. The issue with this is that if it is not done carefully, it exposes a lot of data which attackers can access and steal personal information from users, such as credit card information, addresses, and social security numbers. CSRF, or cross-site request forgery, is a method by which an attacker tricks a user to do an unwanted action such as transfer money without being aware. This can be done by modifying HTTP GET and POST requests on websites that are not CSRF protected. For example, a user can be sent a malicious email from a fake person containing an image. If they click the image, a POST request could be issued to their bank's website, and if their bank is not protected by CSRF and they're logged in, then money can be transferred to the attacker's account. Cookies are pieces of information that are sent from a web app to a client-side web browser to keep track of information while the user is utilizing the browser. Some cookies last only a while during the browsing session, and then they get deleted after. Other cookies are tracking cookies which exist for even when the browsing session is closed. Some examples of information stored in cookies can be passwords, credit card numbers, and emails. Since cookies track a user's information, if they are not sent on an encrypted connection, they can be stolen and used for clickjacking or XSS attacks. That's why it's best if you're transferring a lot of sensitive information in cookies to basically keep it on the server side, not the client side browser, and also to reduce the time limit for how long cookies.
In this demo, I will go over how to configure your web server to use SSL. In order for a web server to support secure connections via HTTPS, it is required to get an SSL certificate from a certificate authority or a self-signed certificate which you can create and install on your web server. This could either be done automatically by the hosting provider or manually through a command line shell. Some popular certificate authorities include Let's Encrypt, Mondo, and Symantec. Let's Encrypt is an open source certificate authority and is one of the most popular ways to get an SSL certificate for free. If we are to deploy the project locally, as we will be doing in this demo, we can generate a self-signed SSL certificate and tell our browser to trust it in order to test the HTTPS functionality. I'll be demonstrating this with a simple Node and Express.js calculator web app with an Angular frontend. The first step is to install all the app dependencies and make sure the app runs on an unsecured connection. After that, we can generate a self-signed certificate and tell our browser to trust it, and then we can modify the Express.js backend web server code to use HTTPS connections. So let's get started. Here we are in our terminal window, and what we're going to do is we're going to go into our angular-express-calculator directory, and then we're just going to type in npm install to make sure we have all the dependencies installed. Once that's done, we could go ahead and we could run our server. So we could type node for Nodejs server.js. And that's going to run the server on port 3000. I'm going to open up Chrome. And if I do a reload, I could see I have my simulator calculator using Node.js, AngularJS, Express, and Bootstrap. You simply enter two numbers and select an operation such as addition, and you get the result. So this all works with an unsecured connection. Let's now make it secured. So the first thing we're going to go ahead and do is make the code changes, and then we're going to go ahead and actually generate the certificates, and then we're going to let the browser trust the certificates. So what we're going to do here in our server.js file in the root directory of our angular-express-calculator Node.js project, we're going to uncomment this line that says on line 5, HTTPS equal require HTTPS, meaning that we want to use HTTPS for the connection. Then we're going to scroll down and we're going to set some HTTPS options here on line 25 to line 28. So we're going to basically set the key. We're going to create a directory called security, and we're going to create a key using open SSL called cert.key. And then we're going to create a cert.pem file as well. Finally, we're going to go ahead and we're going to create our Node.js connections using the HTTPS option. So we're going to comment out what we're doing right now. And here on line 30 to 32, we're going to define the server variable, and it's going to specify https.createServer, HTTPS options. We're passing the options in, and the app, the Express app, and we're listening on the port. So once that's all done, we're going to be able to save this file, and then we're going to go ahead and create that security directory. So if I open up my project, you can see I have a security directory created. And inside we have a request.cnf file. So that's going to specify our self-signed certificate parameters. So if we open up Notepad++, we could take a look at request.cnf. So we could see that we have a distinguished name, we have extensions, we have a prompt, and then we have, for the distinguished name, we have between lines 6 and 11, we have some parameters. So the country, Canada, state, Ontario, the city's Toronto, myself for the company, and department is self. And we have localhost for the CN, basically. So that's the URL we'll be using. And then under here, lines 17, 18, 19, we have some DNS settings for localhost. We have our subject alt names, which is now required for Chrome. So we're basically passing in those alt names that are defined. And we're also setting the key usage. So once that's all done in the request.cnf file, we could go ahead and run the OpenSSL command to actually generate our keys. So I'm going to copy this command, and it's going to generate the keys here. So what I'm going to do is I'm going to go to my security directory, and I'm just going to copy and paste that command. So it's going to run OpenSSL request node days 365, so that means our key will be valid for 365 days.
I'm specifying a new key. It's going to be called cert.key and cert.pem, and we're passing in the config file req.cnf. So if we take a look now inside our security directory, if we refresh it, we could see we have our cert.pem and cert.key. So now what we could do is, once we've done all that, we could go ahead and we could get out of our security directory. And let's go ahead and run our server again, our Node.js server, and we could go ahead and try connecting using HTTPS on port 3000, and we get the not secure for the certificate. So what we could do now is we could click Control-Shift-J to open up developer options. We could click on the two arrows down here and go to security. Under certificate, it says it's missing. Let's click on View Certificate. We'll go to the Details tab, and then we'll click Copy to File. Then we'll click Next. For the export wizard, we're going to leave the format to DER encoded binary. And click Next. We're just going to call it localhost, and it's going to have a .cer extension, and then we're going to click Browse. And I'll just save it in the root directory of our project here. Click Save, and Next, and Finish. And we're going to export that certificate. Then what we're going to do is, in Chrome, we're going to click the three dots at the top right, go to Settings. We're going to click on Certificate, Manage Certificates, and then we're going to go to Trusted Root Certificate Authorities. We're going to click on Import. We're going to click on Next. We're going to click on Browse, and we're going to find that localhost.cer file that we exported. We're going to double click that, click Next. We're going to select Place all certificates in the following store, Trusted Root Certificate Authorities, click Next, and click Finish. And then we're going to click Yes to accept the security warning, and it says the import was successful. We click OK. Now what we should be able to do is we should be able to restart our server, and after it's restarted, we could go ahead and open up a new window in Chrome and go to HTTPS localhost port 3000, and we could see that we now have a secure HTTPS connection using a self-signed certificate that Chrome is trusting. So that's what you could do for testing. If you don't want to use a certificate authority for testing purposes on localhost, we always use a self-signed certificate. And the best way is to use OpenSSL self-sign it and then tell Chrome to trust the certificate. In this demo, I'll go over how to prevent cross-site forgery attack. A cross-site request forgery attack often occurs when a user is logged into a website and then visits another malicious website. The malicious website can have a hidden form which will automatically submit a post-HTTP request to a website that a user is logged into. Since the user is logged into the website that the request is being sent to, all cookies are sent to the web server and an action against the user's intentions may occur. An example of this can be an unwarranted comment or even the theft of money from the user's bank account. A CSRF token is used to prevent cross-site request forgery attack. The way it works is that when a user's browser contacts the web server sends a random string of characters as a CSRF cookie. Anytime the browser wants to do a post request on the web server, they must send the CSRF cookie along with a CSRF token in the HTTP request header. Since the malicious website does not have access to the CSRF cookie, they would not be able to pull out the CSRF token and send it to a web server with a malicious post request. There are a number of ways to do this in Node.js. There's a CSRF module which allows the creation of CSRF tokens, and there's also the crypto module which can be used to generate random bytes to secure a request. So let's get started. Here I am in my CSRF demo project. I just have one server file called index.js, and it's an Express in Node.js project. So let's take a look at this file. So what we're doing here is on lines 1 and 2, we're requiring Express and body parser. Then we're going to create basically two instances. One's going to run on port 3000 of the server, and one's going to run on port 3001. And basically what we're going to be doing is we're going to be sending a cross-site request forgery message from port 3001 on localhost to port 3000. Basically when we send this, if we don't have the CSRF controls in place, if we're not using the cookie, we're going to get, it's actually going to post successfully across sites, which we don't want to happen. So after, we're going to go ahead and turn on that cookie, and then we'll be able to see the request get blocked. So we could see here we simply have a post method here on line 27. We have a form that just basically posts a message that the user enters to localhost 3000, and then that's displayed in the entry route here. It's going to be displayed both as a log message and also on the browser. Then we're going to listen for two ports, both for the original port 3000 and port 2 on line 61, port 3001. And here on line 48, we just have the functionality same as on line 24 for port 3001 to simply display that user text prompt and then submit to localhost 3000 entry /entry for the route. So let's go ahead and run this. So I'm going to open up my command prompt and I'm just going to type in node space dot, and I'm going to see listening on HTTP localhost 3000. So I'll open up my browser. I see I have two instances, one on localhost 3001 and one on localhost 3000. So I could try a message. I'll type in test and click submit, and I see message received test. If I now go on localhost 3001, so this is a separate website, we're going to see if we could cross post to localhost 3000 with that post request. So if I click submit, it says message received test, and if I open up my command prompt, I see that localhost 3000 received two test messages. So this is obviously not what we want, because then we could do malicious cross-posting attacks. So what we're going to do is we're going to add the cserf module and the cookie parser module. We're going to uncomment the lines on lines 3 and 4. And we're also going to add the CSRF middleware. And basically on line 12, we're going to set the cookie to true. Then on lines 21 and 22, we're going to specify app.use cookie parser, and on line 22, app.use CSRF middleware. We're going to scroll down, and then what we're going to do here in the form, we're actually going to enter a hidden input field below the submit, and that's just going to have the name _CSRF, and the value is going to be request.csrf token. So that's going to make sure that basically we have that CSRF token, and that's only going to be sent from the legitimate localhost 3000 web server. It's not going to be sent from 3001. So what's going to happen in this case is that we're going to see that basically once we save it and we go ahead and we make sure that we do an npm install to make sure all the packages are installed, we're going to make sure and try that cross post request and see that it fails. So let's open up the command prompt. We're going to close this session. We could run an npm install just to make sure that our packages are installed. So the cserf package as well as the cookie browser. And then we're going to go ahead and run it again. And now if I go back into my browser, I'm going to go back to localhost 3000. I'm going to try it out once again, send test and message received test. Now I'm going to go to 3001 on the port, so localhost 3001. I'm now going to try to send that same test message again to localhost 3000, and I get a forbidden error, invalid CSRF token. So that's basically how we've secured our site. So now we're preventing the malicious post request, because that post request does not have that CSRF cookie token, and we could only post from the same origin or from the same URL.
In this video, I will go over how to analyze logs using the ELK stack. Modern log management solutions need to have the capability to aggregate, store, process, and analyze data effectively. Aggregation is the ability to use several different sources of data in order to collect and send data. Examples of this include IoT devices, which are all different sources of data, sending the data into a log management platform where it becomes better organized and searchable. Storage is another necessity with modern log platforms. Ideally, data should be stored in the cloud within easy and secure access and high availability and fault tolerance. Processing deals with transforming the cryptic log messages into meaningful insights to drive business and security decisions. Finally, analysis features allow data to be queried and displayed in graphical formats and dashboards in order to more easily interpret it. The ELK stack is composed of three main components. These are Elasticsearch, Logstash, and Kibana.
Elasticsearch, based on the Apache Lucene search engine, is used for log search and text analysis to gain insights from log messages. It is open source. Logstash is a log aggregator which uses various sources to collect input data and then applies transformations to the data before sending it to output. Kibana works alongside Elasticsearch and allows the querying and creation of visualizations using data from Elasticsearch. These three components, when working together in the ELK stack, allow the easy monitoring of log files in order to aid troubleshooting and securing full-stack web applications. Benefits of the ELK stack include a user interface, data visualizations, and an extensible source. A browser-based user interface is provided by Kibana in order to help visualize and analyze data which is stored in Elasticsearch objects more easily. Kibana has a very useful data visualization layer which runs alongside Elasticsearch and Logstash. Visualizations such as bar charts, coordinate maps, and time series charts can all be created with Kibana, as well as many types of custom visualizations. The ELK stack provides an extensible REST API and a plugin architecture, with plugins ranging from alerting to data ingestion and security in order to meet any log management need. Elasticsearch is mainly used for log search and analysis in the ELK stack. It is high performance and stores data in an unstructured way, and because of this, is classified a NoSQL database. Elasticsearch is mainly used for the indexing and storage of data in the ELK stack, and can query data using either the URI search functionality, REST API, or SQL statements. Elasticsearch also provides plugins, both core and community, to enhance features such as security, API features, data discovery, and data analysis. Elasticsearch holds data in documents which are stored in logical partitions called indexes. Types divide similar data in documents, and mapping is present to specify the type of data in an index. Shards enable indexes to be spread out into horizontal partitions for better performance. Shards can also be made into replicas to recover from system failures. Logstash is used for ingesting, transforming, processing, and outputting large quantities of data into storage from multiple unstructured data sources. It is built with a plugin architecture and can load, transform, and output many different types of log data. Logstash handles log data in 3 steps. The first step is to define an input plugin to specify the source and type of data being ingested. The second step involves specifying filtering operations on the data, which will determine how the logs are massaged or processed. Finally, the last step is to specify an output plugin for the data to push the data to storage or various services such as Elasticsearch or messaging queues such as RabbitMQ. Logstash also supports codecs to decode incoming data and encode outgoing data in different formats such as Json. Kibana uses Elasticsearch indexes to search, analyze, and visualize data stored in Elasticsearch. It can be used to create dashboards as well as interactive charts with Elasticsearch data. Kibana runs as a web application in the browser and is open source. Kibana is used to search for specific Elasticsearch log messages by using the KQL or Kibana querying language. Kibana also has the option to add filters to only display log messages containing specific strings on the main log display. Some of the types of visualizations which can be created using Kibana include line and bar charts, data tables, coordinate and regional maps, time series charts, and control charts. In this video, I'll identify OWASP's top 10 security risks. The Open Web Application Security Project, or OWASP, Top 10 Security Risks document is a document published every 3 to 4 years containing the 10 most pertinent security risks affecting web applications. It is written with the intent to enhance a security culture within organizations and to minimize the security risk exposure of web applications. Top security professionals around the world convene to come up with the OWASP Top 10 list. The first OWASP security vulnerability is injection. An injection attack occurs when an attacker sends data that is not valid input to a web application in order to trigger an action outside of the web application's design. Injection attacks may occur if a web application does not have the proper input validation safeguards in place.
Broken authentication means that a website has a vulnerability in authenticating users and that an attacker can gain access to a user or administrator account by ways such as brute force attacks to guess the username and password. Sensitive data exposure deals with improper security measures on sensitive user data such as credit card numbers and emails. Sensitive data can be both found in storage or during transit between web servers or a server and a browser. If a web application has an improperly configured XML parser, it may become vulnerable to XML external entity or XXE attacks. The idea is that an attacker can upload an XML document to a web server containing references to malicious external entities. Broken access controls deals with users that can see parts of the websites that they should not be able to see. For example, a regular user being able to see the administration page. And if they have the ability to do this, they could harm the web application. Security misconfigurations are another threat. This can happen if a website package isn't patched or updated properly, or if things such as file system permissions are not adequately set. It is often advisable to harden security from default settings to prevent these attacks. XSS or cross-site scripting attacks use a web application as a method for propagating malicious content by injecting client-side scripts into the web application code. They often require user action to trigger, such as visiting a particular web page. Insecure deserializations deal with accepting serialized objects from various sources which may not be trusted. Serialization is the process of converting an object in code to a byte string, and deserialization is the reverse. Serialization and deserialization are used to transmit data. Broken components is a web security risk where various packages used in a web application are not kept up to date either because of the speed at which updates come out or because newer versions of a package aren't supported by other parts of the web application. Finally, the last OWASP threat deals with insecure logging and monitoring. If a web application is not using logging and monitoring effectively, it becomes exceedingly difficult to figure out where and why a security breach occurred and how it can be prevented in the future. In the next 3 slides, I will cover each security risk in more detail and will explain ways in which it can be avoided. Injections, as I mentioned, deals with an attacker sending data that is not valid input into a web application in order to trigger an action outside of the web application's design. An example of this is a SQL injection where a malicious query can destroy a database. It can occur if a web application requires a username, for example, and then the attacker instead enters a SQL query to get untrusted data. Injection attacks can be avoided by offering a secure API with a parameter-based input, escaping special characters, and using a white list of allowed terms for server-side validation. As I mentioned previously, broken authentication means that a website has a vulnerability in authenticating users. The 2 most common ways attackers exploit this flaw is by accessing the admin login page of a website and then using a brute force attack where they can employ a brute force method to guess the password and username of the administrator. Ways to prevent broken authentication are to add multi-step authentication, for example with an email or text message verification, and also to lock out users who fail to log in after a certain number of login attempts. Sensitive data exposure deals with improper security measures on sensitive user data such as credit card numbers and emails. Sensitive data has to be secured while both at rest, in storage, and in transit. A failure to encrypt sensitive data both in storage and in transit with SSL and HTTPS connections are examples why sensitive data breaches occur. Another vulnerability is the storage of too much unnecessary sensitive data on a web server. If a sensitive data breach occurs to a big business, such as what happened to Target a few years ago, it has major repercussions both financially and in terms of a business's reputation. If a web application has an improperly configured XML parser, it may become vulnerable to XML external entities or XXE attacks. Often these attacks occur if a user is allowed to upload XML documents and they put malicious content or code into the document. Since most XML parsers are by default at risk for XXE attacks, it is up to the developers to prevent them. Ways to prevent XXE attacks are to simplify the types of data used, for example to use JSON types instead of XML, disable the addition of external XML entities, and to keep the XML processors up to date with the latest patches and updates. Broken access control deals with controlling which users can see which parts of the website. An example of this would be a WordPress blog, where regular logged-in users are given admin rights and access to the administrator dashboard where they can add, delete, and update blog posts. Users may also have access to FTP, SSH, and the web application database.
The best way to prevent broken access control is to deny or restrict user privileges by default to no more than what they need, and to monitor all user activity across the web application to ensure that unprivileged users aren't accessing the secure areas. Security misconfigurations can happen if a website package isn't patched or updated properly, or if things such as file system permissions are not adequately set. With modern CMS platforms such as WordPress, attackers may exploit the fact that many admins don't change the default configuration settings. Another risk factor may be that attackers can view directories on the web server and download libraries and application code. Ways to harden security and avoid security misconfigurations include the removal of unnecessary features, documentation, and samples, and the automated configuration process of the development QA and production environments. XSS or cross-site scripting attacks use a web application as a method for propagating malicious content by injecting client-side scripts into the web application code. They often require user action to trigger, such as visiting a particular web page. Oftentimes, an attacker will hide or change the display of the malicious script, and the user will load it in their browser without them knowing that they did so. WordPress has a known XSS vulnerability, and an attacker may use this to go into a post and vandalize it, posting malicious client-side JavaScript code within it. Ways to get around XSS vulnerabilities include using frameworks such as Ruby on Rails or React, which by default escape XSS, and escaping untrusted HTTP data when it gets requested to the web server. Insecure deserializations deal with accepting serialized objects from various sources which may not be trusted. Serializations, as I mentioned, is the process of converting an object in code to a byte string, and deserialization is the reverse. An example of a vulnerability involving insecure deserializations is when an attacker intercepts a serialized supercookie containing the user ID, password, and user state. The attacker can then deserialize the cookie, modify it so they gain admin privileges, and then reserialize it again to compromise the web application. Ways to secure websites against these risks include running code that deserializes in low-priority environments, implementing integrity checks on serialized objects, and enforcing strict type constraints on deserialization. Broken components is a web security risk where various packages used in a web application are not kept up to date either because of the speed at which updates come out or because newer versions of a package aren't supported by other parts of the web application. The best way around this is to update packages regularly, and if there is not a possibility to do this, to implement a virtual patching system incorporating a firewall to protect from known vulnerabilities. If a web application is not using logging and monitoring, it becomes exceedingly difficult to figure out where and why a security breach occurred and how it can be prevented in the future. By lacking logging and monitoring, it would also take longer to detect a security breach, and an attacker would impact the website at a greater rate. Using a log management platform such as the ELK stack can help with improving logging, as well as keeping audit logs with a summary of events occurring on a website over a period of time. In this demo, I'll configure HSTS on web servers. HSTS, or HTTP Strict Transport Security, is a method of web security by forcing connections to go over a HTTPS encrypted connection for a set period of time. The web server specifies a Strict Transport Security, or STS, HTTP header sent to the user browsers, which outlines that only HTTPS connections are accepted for this set period of time. If a user tries connecting with an HTTP connection, their request will not be rerouted to HTTPS but will be instead denied. HSTS is more secure than regular HTTPS because it does not accept HTTP redirects to HTTPS, which in the case of standard HTTPS opens up a security vulnerability for attackers to sniff network data. Projects built with Nodejs and Express have middleware modules designed to implement HSTS and set the strict transport security HTTP header on the web server. One such module, which is the most commonly used, is called Helmet. So let's get started. Here I have my Angular Express Calculator app that we covered in a previous video where we were securing it with HTTPS. We could go ahead and run the app and make sure that it works as it did before by typing in node space dot in the root directory, and I'm just going to open up the server and go to localhost 3000 in HTTPS connection. I get the connection is secure. I could enter two numbers and do various operations such as multiplication and get the result. So now that we see that the app works, what we're going to do is we're going to open up a second command prompt, and we're simply going to run a curl command So for those of you using Windows 10, curl does come pre-installed with Windows 10. It also comes installed if you install Git on Windows. So I'm going to specify curl space https://localhost:3000 for the URL, and space -- include, which is going to display all the response headers. So once I do that with curl, I'm going to get the HTTP request passed OK. And as you can see on the first line, it says x-powered-by express. So we definitely don't want to have this line in here because a potential attacker could see that we have an express app and try to manipulate those vulnerabilities. We also see we have some other things in here. We have the content link, we have the last modified cache control and accept ranges, and so on. So what we're going to be doing now is we're going to be turning on HSTS, and then we're going to see a few more fields show up in the response header. So let's go back to our code. What I'm going to do is I'm going to first edit the code, and then I'll import the helmet module. So what we want to do is in server.js in our main server file, we want to specify on line 8, helmet equals require helmet. And then we want to scroll down on line 19, uncomment this line app.useHelmet, so that's going to tell the application to use the helmet middleware module. And then that's all we basically need to do. So helmet already comes with a predefined time for HSTS of 1 year. Everything's configured out of the box. So once we do that, the third step is we just have to save, and then we have to open up our command prompt, and we have to make sure that helmet is installed. So we'll do npm space install space helmet space -- save. That's gonna install helmet and save it to our dependencies. And then we could go ahead and we could rerun the code. So node space dot in the root directory. You see server running at 3000. We could open up the browser, just make sure everything works as expected. We could see the application is still there. Now we're going to go back to our other browser, to our other command prompt, and we're going to go use curl again, and we're just going to rerun that https localhost 3000 command with the -- include flag. And as you can see here, we have a few more flags in the response header, so we could see that we no longer have that flag that we had before for the X powered by Express, so that's good, so attackers won't know what technology we're using. We see we have this STS, or strict transport security header in, so that's for HSTS. It's specifying the max age in seconds and including subdomains for HSTS, so basically the whole website's secured. And it added a few more security features such as the X content type options, no sniff, and so on, because the helmet module actually contains more than just HSTS. It contains a few other things for security protections, basically against XSS, sniffing, and so on. So that's how we could go ahead and enable HSTS on a web server for a Node.js Express project.
In this video, I will go over how to prevent cross-site scripting attacks. As I mentioned in previous videos, a cross-site scripting attack, or XSS attack, occurs when an attacker injects malicious client-side code, most often JavaScript, into a web application. This code is then run by a user's browser who is visiting the website. Oftentimes, the attacker disguises the client-side script to prevent users from knowing it is there. The two most common types of XSS attacks are reflective and persistent. A reflective attack is the most common, and it occurs when an attacker enters an HTTP parameter for querying and displaying a malicious web page. The second type of XSS attack is a bit less common. Persistent XSS attacks actually store attacker data on the web server and present the data as a normal page on the website. The x-xss-protection header can be used on an HTTP request in order to turn on the cross-site scripting filter, which most modern browsers such as Chrome, Firefox, and Internet Explorer support. With the mode equals block flag set, the browser will prevent loading and displaying a page containing malicious scripts instead of sanitizing them. In a Node and Express.js project, we can use the helmet middleware module to turn on the x-xss-protection header for modern browsers. So let's get started. Here I have my Angular Express calculator application. I'm just going to go ahead and run it to make sure everything's running as expected.
So go into the root directory and type node space dot. That's going to launch it on port 3000. I could go on and I could connect to it. I see I have an HTTPS connection and I see connection is secure. Now I could open up another command prompt, and using curl, I could simply specify curl HTTPS : and then my address localhost : 3000 -- include, which is going to print out all the HTTP headers. And let's take a look. So we could see we have the HTTP headers and that the x-xss- protection field is not set in the HTTP header. So let's go do that. So what we're going to do is we're going to edit the code first. So if we open up the Atom code editor, and we could see we have our server.js main server file in our angular-express-calculator Node.js project. What we're going to do is we're going to uncomment the line on line 8. So we're going to require helmet. And then we're going to scroll down on line 19, and we're going to specify app.use helmet.xss filter. So we're using one of the helmet middleware modules features for the XSS or cross-site scripting attack filter. And that's the only 2 lines that we have to change. We'll go ahead and save the file. Then we'll go back to our command prompt. We want to make sure that helmet's installed. So inside our root directory or project, we're going to type in npm space install helmet -- save to save it to our dependencies. Once that's installed, we could go ahead and rerun our project, node space dot, and we could open it to make sure it's working and reload it, and we could see it's still working. Then we're going to open up curl again, and we're simply going to run the curl command. So curl https : // localhost : 3000 -- include. Now we should see our HTTP header change. So we could see that we have this x-xss- protection field set. We could see it's set to 1. So basically, if we didn't have the 1 here, it would mean that it's turned off. So we definitely wanted set to 1 for modern browsers to have the cross-site scripting protection on. Now, if we didn't have this mode equals block at the end, we would simply sanitize any suspected cross-site scripting attacks and still display it or render it to the user in the web browser. Since we have this semicolon mode equals block after it, that basically means that if we do have any type of cross-site scripting attack suspected, the browser will prevent loading and displaying a page containing the malicious scripts instead of sanitizing them. So that's how we could go ahead and turn that flag on. Additionally, one thing we could do is we could, instead of just specifying the helmet.xss filter, we could simply just specify app.use helmet, and we could save it and rerun the Node.js server. And if we do that and we rerun our curl command, what we're going to get is we're simply going to turn on all the helmet middleware protection. So we could see that we now not only have x-xss- protection, but we have no sniff protection. We also have HSTS protection and so on enabled in the header. So that's how we could go ahead in a Node.js and Express.js project to turn on cross-site scripting or XSS protection. In this demo, I'll go over how to defend against clickjacking attacks. The basics of a clickjacking attack are that an attacker wants a user to click something that the user doesn't want to click. The way they achieve this is by hiding the button they want to be clicked and then underlying it with a legitimate, visible, trusted web page in an iframe. This can fool the user into thinking they are clicking a legitimate button, whereas instead they are actually clicking the malicious hidden button. The attacker can then use this click to steal user data such as passwords, credit card numbers, and also it can trigger a download of malware onto the user's computer. Luckily, it is possible to prevent a clickjacking attack by setting the x-frame-options HTTP header in order to prevent an attacker from putting a website into an iframe. There are 3 settings which can be specified in the header. A website can specify deny to deny any iframe request, same origin to only allow iframes to be used on the same origin or URL as the page itself, and allow from and specify a list of URLs where it is possible to specify which websites can use a website within an iframe. Generally speaking, most websites choose the deny or same origin setting if they aren't planning on using iframes on different websites. For a Node.js and Express.js project, it is possible to use the helmet middleware module to turn on the x-frame-options HTTP header. So here we are in the Atom code browser, and we could see we have our angular-express-calculator Nodejs and Express project, we could go ahead and run it just to make sure it works. So inside the root directory, we'll type in node space dot, and we'll see it runs on port 3000. We could then reload the page, and we have our secure connection, and we see our calculator application is running. So now what we're going to do is we're going to turn on the clickjacking attacks by using the Helmet middleware. So back inside the code in our root directory server.js main server file, we're going to go to line 8 and uncomment the require helmet command, so basically requiring helmet for the middleware module. Then we're going to scroll down and we're going to uncomment the line at line 19. So we're going to specify app.use helmet.frameguard. So that's going to set up our clickjacking protection with the same origin default setting. We're just going to go ahead and save this file. Then we're going to make sure that helmet is installed. So we're going to close the server and we're going to run npm install helmet space -- save within the root directory of our Node.js project. Once that's installed and added to the dependencies, we could then go ahead and we could rerun our project with the node space dot. We could reload it, make sure everything's loading as expected, and then we could open up a second command prompt and we could scroll down and we could access the curl command. So we're going to run curl space and we're going to enter the URL https://localhost:3000 space -- include to include the HTTP headers, and we could see here that we have this x-frame - options added to the HTTP header, and it's specifying same origin. So this basically means that iframes can only be posted on that website URL, and a foreign website couldn't post an iframe of our website for a clickjacking attack. So now what we're going to do is we're going to change that same origin to deny, to basically say deny all clickjacking attacks and deny all posts of iframes, even if it is on the same origin. So if our website wants to post an iframe within itself, it won't be allowed to do that. So that's the most strict setting on that HTTP header. So what we're going to do is we're going to uncomment line 20 and recomment line 19. If we take a look at line 20, it says app.use helmet.frameguard, and we're going to specify action : deny. So the default action is same origin. We're going to specify the deny option, and we're going to save that. We're going to restart our Node.js Express server, and then we're going to issue that curl command again in our second command prompt, and we'll scroll up and we'll see that the x-frame - options : is set to deny. So that's the most strict setting. Generally speaking, websites are going to want to either have the deny or the same origin setting if they're not planning on using iframes on different websites or different domains. So that's how we could go ahead and prevent clickjacking attacks by setting the x-frame - options header from a Node.js and Express.js project. In this video, I'll go over how to prevent cross-site scripting or XSS attacks using a Content Security Policy or CSP. A Content Security Policy is an extra layer of protection against cross-site scripting or XSS and data injection attacks. It is turned on by setting the content-security-policy HTTP header. The header allows you to specify a whitelist of sources which are trusted and which the browser is allowed to execute. CSP is built in to be backwards compatible. This means that if a browser doesn't support CSP, the header is ignored and the same origin rule is used instead. If a browser does accept CSP headers, but they are not activated on the web server, the default same origin rule will be used instead. It is also possible to define the CSP directly in the HTML page markup using the meta HTML tag and the HTTP-equiv attribute. Two of the main purposes of CSP is to stop XSS and packet sniffing attacks. XSS attacks, as I mentioned in previous videos, deal with attackers placing malicious client-side scripts into a web page, which are then executed by a user's web browser. By using CSP and having the ability to set a whitelist of trusted sources from which valid scripts can come from, administrators can prevent attacks from unknown sources. Packet sniffing attacks can occur if a connection isn't using a secure HTTPS connection to transfer data. CSP can specify which policy to use to transfer data, and also it can specify that only secure cookies are to be used. Additionally, CSP can redirect all HTTP requests to HTTPS to prevent unsecured connections. There are two steps to implement CSP. The first step is to specify the policy in the HTTP header, and then to write the policy in order to define the rules for trusted sources for resource types. The content-security-policy header implements the policy, with the policy being a string of different directives and rules describing the content security policy. When writing the policy, it is important to implement a default-source attribute which blocks eval and prevents inline scripts from running. The default-source attribute also specifies a default policy for resources that do not have their own policy defined. Some common CSP policies use cases are specifying the use of a site's own origin for resources, requiring SSL for secure HTTPS connections, trusting domains and subdomains, and restricting audio and video file sources. To use all resources from a site's own origin, the default-source and then self-directive can be specified. Additionally, the administrator may want to include wildcards to other supported websites for resources. For example, they may specify default-source self and then a space star.google.com to use all resources from Google and its subdomains. If an administrator only wanted secure documents being loaded from Google, they can specify directives such as default-source https://google.com, which will make sure that all the documents come from an HTTPS connection from Google. The image-source and media-source directives can be used to restrict or allow certain images and video and audio media sources. For example, if the media-source directive is followed by a star, the policy will allow all media sources for video and audio. By using the report URI directive in a content security policy, it is possible to turn on policy violation reports, which are turned off by default. It is also necessary to set up a URI to send the reports to if policy violation reporting is turned on. The report is sent as a JSON object and contains the various violation statistics. Blocked URI specifies the URI which was blocked by the CSP. The disposition field specifies if the CSP is the report-only mode, where reports are created but the CSP isn't enforced, or if it is in the normal enforce mode. The report-only CSP mode is set by defining the content-security-policy-report-only HTTP header instead of the content-security-policy HTTP header. Document URI specifies the URI of the specific document where the violation occurred. Affected-directive shows the directive which needed to be enforced to prevent the violation. The original-policy directive is the policy which is specified by the content-security-policy header. Referrer is the person who referred the document where the violation was present. The CSP violation report is a JSON object sent as a POST request to the URI specified in the report-URI directive. It contains the directives mentioned in the previous slide, such as block-URI, effective-directive, script-sample, status code, and violated-directive. Different browsers will use different directives in their reports. For example, a CSP report for the same issue in Chrome may include the effective-directive, violate-directive, and status-code directive, while in Firefox, only the effective-directive would be included. This may make it more difficult to identify problems if using various browsers. In this video, I will cover how to prevent the caching of sensitive data. A web browser stores information about web pages for two primary reasons. The first being history, where a page location is saved for quick retrieval, and the second being caching, where page content is downloaded onto a user's device in order to more quickly load a web page when it is being visited again. Sensitive user information such as credit card numbers and passwords can be stored in cache, and that can cause a potential security risk. In order to mitigate this, a cache control header can be used. A HTTP cache control header is used to specify policies for browser caching in both client requests and web server responses. Some of the policies in the cache control header may include where and how a resource is cached and the time to live for the resource in cache. The HTTP cache control header is cross-origin resource sharing or CORS safe, listed, meaning that the cache control header is considered safe and will not be filtered out when processed by CORS. The cache control header is not a forbidden header name, which means that the HTTP header can be modified programmatically. The cache control header syntax includes cache request directives, cache control directives, and cache response directives. The cache request directives are used by the client in an HTTP request. There are various cache request directives such as no store, no cache, max age, and only if cached. The cache response directives are used in an HTTP response to the web server. Some of the directives include no store, public, private, and max age. The cache control directives include the immutable, stale while revalidate, and the stale if error directives. These directives are not part of the main caching standards for HTTP. Some of the cacheability directives include public, private, no store, and no cache. The public cache directive is used to indicate that any cache can cache a response even if the response is deemed uncacheable. An example of an uncacheable response would be one that lacks a max age or expires header value. A public cache directive is best used for websites with high demand and rarely or infrequently changing data. A private directive will show that a response is for a single user only and will stop a shared cache such as one found on a proxy server from caching the response. A private cache is better than a public cache for serving data over HTTPS connections and where cookies and user accounts are used. A no cache directive would be used to force a request to the origin server for validation before caching occurs. This basically means that before a request can be satisfied from cache, the URL needs to be first checked with the server to make sure that the server response didn't change. An eTag validation token is used to ensure the cache is still valid. This directive is best used for frequently changing resources and for time-sensitive resources. No store is used to specify that a server shouldn't store anything about a server response or client request in cache. This is the best option for sites dealing with personal, sensitive data such as banks. In this case, a full download occurs for all resources when they are requested. Expiration directives deal with how long the resources stored in cache remain usable. The max age directive indicates in seconds how long a particular resource can be used from the time it was requested. The s-max age directive has priority over the max age directive, but is only valid for shared caches and will be ignored by private caches. The max stale directive, just as it sounds, indicates the number of seconds that a client would be willing to use a response that has gone beyond its expiration time. Min-fresh indicates that the client desires a response that would remain fresh or valid for at least the number of seconds specified in the parameter. Stale while revalidate means that a client will accept a stale response for a number of seconds while in the background a fresh response is being searched for. Stale if errors is a directive which can be used to indicate the number of seconds a client is willing to use a stale response if the search for a fresh response fails or has an error. Revalidation deals when a browser is reloaded and the resource in cache needs to be checked to ensure that it is still valid. If it is not, the cache must be updated with the latest changes. The must revalidate directive specifies that if a resource in cache has exceeded its max age time, that it should not be used without a successful validation from the host server. This basically means that the return of stale responses will be refused. The only difference between must revalidate and proxy revalidate is that the proxy revalidate deals with shared caches and is ignored by private caches. Immutable deals with resources that don't change frequently. If the resource has the immutable directive set, the client when making a request does not need to send a conditional revalidation in order to check for updates on the server. Immutable helps in improving performance and reducing the number of HTTP requests and 304 codes or not modified responses. In this demo, I'll go over how to secure cookies using cookie directives and cookie prefixing methods. The intent of cookies is to help identify unique website visitor session information, since HTTP requests do not carry state information. If cookies are used, each request made to a server includes cookies from the user's browser. The same-site cookie directive is designed to help a browser with the decision of whether to send cookies with a cross-site request to a third-party website. It can be set to either a strict value, where all cross-site requests are sent without a cookie, or a lax value, where a balance between usability and security is used for logged-in users. In lax mode, cookies are only sent with GET requests that change a web URL, such as with HTML link href tags. Most modern browsers, such as Chrome and Firefox, support the same-site cookie attribute, and as a result, CSRF attacks have been declining. Cookie prefixing methods include using the __ secure and __ host prefixes in the cookie names. The __ secure prefix ensures that a cookie is sent only over a HTTPS connection and that the secure directive is used in the set-cookie HTTP header. The __ host prefix is even more strict and requires that the secure directive is present in the set cookie header along with no domain directive, as a request is sent only to the host which set the cookie, and a path attribute value of / needs to be set as well with the __ host prefix. In order to use the secure cookies in Node.js and Express.js projects, we can use the express-session middleware module for Express.js. This middleware stores only the session ID in the client-side cookie, and the actual session data is stored on the web server. So let's get started. Here I am in my Atom code browser. I'm in the Angular-Express-Calculator Node.js and Express.js project, and I'm going to open up the server.js main server file. Within this file on line 8, I'm going to uncomment this variable session. So const session equals require express-session. So that's the module we'll be using for the secure middleware. Then between line 20, I'm just going to delete this comment to line 34. I'm going to actually be setting the session and the cookies. So I'm going to make sure that since I'm using the host prefix on line 23, the name of the cookie is going to start with __ host, and it's going to be called __ host -localhost. So because I'm using this, I need to set the secure attribute to true. So in my cookie settings on line 30, I'm setting secure to true. And I also have to make sure there's no domain attribute set. So there's no domain attribute set in my session settings. And I could also see that if I go to GitHub, I could take a look at express-session and I could see that there's no domain attribute set by default. Then I'm going to also make sure that my path attribute is set to /. Once again, in GitHub, it states that within this express-session middleware module, the path is set to /, and that's needed because we need to send basically the cookie with every request to that host that set it. Then on line 25, I'm going to set a secret string, which is going to be used to sign the session ID for the cookie. On line 27, I'm going to set resave to false, so it's basically going to say don't save the session again unless it was modified. On line 29, I'm going to set save uninitialized to true. So that basically means to save new unmodified sessions to the cookie store. And between line 30 and 33, I'll set the cookie settings. So secure will be set to true. So that basically means that once again, we're going to need HTTPS connections to send the cookies, and we need that for the __ host prefix. And same site on line 33 will be set to true. So by setting same site to true, we're using the strict settings for the same site directive. Otherwise, we could set it to false to turn it off. We could set it to strict, which will do the same as true. We could set it to lax for the lax settings, and none, which will just insert a none value. Let's go ahead and save this file. Then we'll go back to our command prompt, and within our Angular-Express-Calculator directory, we'll run npm install space, and we're going to want to install express-session, and then space -- save to save it to our dependencies. Once that's installed, we could go ahead and we could run our project by typing node space dot in the root directory. We could go and access our calculator application, make sure that it works. And then we'll go and to a second command prompt, and we're just going to execute a curl command. So curl space https / / localhost 3000 space -- include. And we could take a look at this HTTP header. We could see that we have the set - cookie attribute set. So we could see we have our __ host prefix. We have our path, so that's set to /. We have HTTP only, and we have secure, and we have the same site directive set to strict. So that basically means that's pretty much as secure of a cookie as you could get. Now, it might not be the best for performance, but in terms of cookie security, by having all these settings turned on and set in the set - cookie header, along with the __ host prefix, that's about as secure of a cookie as we could get. In this video, I'll go over how to prevent cross-site request forgery attacks by using the same site cookie attribute. The intent of cookies is to help identify unique website visitor session information, since HTTP requests do not carry state information. If cookies are used, each request made to a server includes cookies from the user's browser. A browser only sends a cookie along with a request to a web server if the data and flags in the cookie match the web server that the request is being sent to. Cross-site request forgery, or CSRF, exploits the fact that cookies can be sent to a third-party website or a website which the user does not directly visit. An example of this would be a website which loads a Facebook like button from Facebook, and then the browser cookies are also sent to Facebook.
In this way, an attacker can use a logged-in user session to execute unwanted actions, changing the user state and behave as an authorized user. Additionally, third parties can abuse cookies to target advertisements based on user search preferences along with tracking their online activities. There are several ways to secure users from CSRF attacks. Token-based mitigation can be achieved using either stateful or synchronized token patterns, or stateless encrypted token patterns, and is one of the most popular ways to mitigate CSRF attacks. In the synchronized token pattern, a state change needs a CSRF token, which is a cryptographically generated large value and is unique for each user session. The token can be located in JavaScript forms or AJAX calls. This token is submitted with a user request and is then verified by the web server to make sure the request was legitimate. For applications that don't want to keep a server-side state, encryption tokens are a better choice. The encryption token is built using the user's session ID, timestamp, and a unique encrypted key located on the server. This token is then returned to the client, and when the client makes a request, it needs to be successfully decrypted by the web server to allow the request. HMAC is similar to encryption-based CSRF protection as it does not store state. The difference is that it uses the HMAC function, SHA-256 or stronger algorithms instead of an encryption function to generate the tokens. Auto CSRF mitigation deals with the fact that sometimes developers forget to add tokens to state change operations. Examples of auto CSRF mitigation are the use of wrappers and hooks to auto add CSRF tokens and adding tokens automatically to the client side using scripts. Using CSRF protection on login forms is also important and can be implemented by creating sessions before the user is logged in or pre-sessions along with adding tokens to the login form. The same site cookie attribute is designed to help a browser with the decision of whether to send cookies with a cross-site request. It can be set to either a strict value where all cross-site cookie requests are denied or a lax value where a balance between usability and security is used for logged-in users. It is supported on most modern web browsers. Defense in depth techniques, along with the same site cookie attribute, help to secure against CSRF attacks. The first step of the defense in depth technique is to verify the source origin with standard headers. Since the HTTP header cannot be altered in a programmatic way, the headers are considered reliable. The source origin is checked against the target origin, and if they match, then the request is valid. Otherwise, a cross-site request occurred and it is blocked. The source origin can be checked in the source header, and if it is not present, the referrer header can be used. To find the target origin, the application can either know its target origin in the server config file or use the host-header or x-forwarded-host header value in the application in order to find its target origin. If your domain uses HTTPS and you don't want to maintain CSRF token state on the server side, a double submit cookie technique may work. In this method, a random value is generated by the server and needs to be included by both the cookie and request parameter. Sometimes it is complicated to use double submit cookies, CSRF, and encrypted tokens as there are a lot of changes required to the user interface code. A custom request header can be used in place as by the same origin policy, JavaScript by default in most browsers is not blocked from making cross-origin requests. One of the most popular headers to use is the x-requested-with XML HTTP request header as it is present in most JavaScript libraries. A server would simply have to verify that the header exists and that all AJAX endpoints have a good value, and the application would be protected from CSRF attacks without any code changes to the user interface or server-side state tracking. This is particularly useful for REST web-based applications. User interaction-based CSRF defense deals with using things such as CAPTCHA fields, one-time tokens, and re-authentication in order to stop CSRF attacks. The downside to these methods is that they often impact user experience. Nevertheless, high-security web applications should use a combination of user interaction-based CSRF defenses and token-based mitigation. There are several CSRF defense techniques which are not effective. The secret cookie CSRF defense technique is flawed because it will still be submitted with all other cookies during a request even if the browser submitting the request was fooled into doing it. The idea by only accepting post requests was originally that an attacker can't build a harmful link through a post request and that a CSRF attack would be avoided. This is false, however, as an attacker can have a hidden form on a web page which auto-submits using JavaScript. Multi-step transactions are also an ineffective CSRF defense as an attacker can simply figure out the steps of each transaction and then form an attack from there. URL rewriting hides a user's session ID by changing the URL. This is an issue, however, as the session ID of the user is still present in the URL and introduces a new security flaw. HTTPS does not protect against CSRF attacks on its own, however, in conjunction with other techniques, it is useful. So in this course, we've examined best practices for secure programming when trying to protect the various layers in full-stack development. We did this by exploring how secure programming applies to full-stack developers, how to configure SSL and prevent cross-site forgery attacks, analyzing logs using the ELK stack and identifying OWASP's top security risks, how to configure HSTS on web servers, and how to prevent cross-site scripting and clickjacking attacks, the prevention of XSS attacks using CSP and the caching of sensitive data, and the identification of cookie prefixing methods and the prevention of cross-site forgery attacks using the same site cookie attribute. In our next course, we'll move on to explore the technologies of the mean stack and the importance of mean stack in FSD development.
Spring is a very popular framework among Java developers for creating enterprise applications. Before getting into the weeds of the Spring framework, let us understand the evolution of Java enterprise application development and the need for Spring framework. So before Spring framework, how did Java developers create web applications? They used Java beans. Java beans are plain old Java objects, commonly referred as POJO, which helped in the creation of user interface components. Although the usage of Java beans had various advantages, it lacked in two areas: security and transaction management, which are crucial for building enterprise applications. Then came Enterprise Java Beans, referred as EJB, which address the key concerns of transaction and session processing, along with few other additional features. However, developing an EJB application is not simple and straightforward, and that involved a series of tasks and configurations. Due to these complications, developers started looking for alternative options to create web applications. Spring Framework emerged as an answer to all these complications. Spring is an open-source lightweight framework that integrates well with some of the key J2EE specifications, such as dependency injection and common annotations. This framework uses three main technologies for developing enterprise applications, and they are Aspect-Oriented Programming, AOP, which enables the users to implement cross-cutting concerns in a centralized area, plain old Java objects, commonly referred as POJO, dependency injection, which is a Java Enterprise Edition specification. Spring Framework has a lot of key features that makes it unique among other frameworks. Let's explore them one by one. IOC container. IOC, also referred to as inversion of control, is a core container that uses dependency injection to implicitly instantiate objects during runtime. This container also handles the configuration management of application objects. Spring MVC framework. This framework allows the developers to create web applications using the MVC architecture. Typically, all requests made by the user flows through a controller and gets dispatched to the model or view based on the mappings. This framework can be integrated with all front-end technologies. Data Access Framework. This framework allows developers to use persistence API, such as JDBC or Hibernate, to store or access data in the database. Some of the key developer concerns, such as connecting to the database, interaction with the database, closing the connections, or exception handling, along with transaction management, can be handled easily with Data Access Framework. Transaction Management. This framework provides Java Transaction API, JTA, for global and local transactions. It enables the developers to create a wide range of transactions on the basis of Spring declarations for transaction management. Spring Web Services. Spring provides powerful mapping mechanism for distributing the messages between two machines. It generates web service endpoints and definitions based on the Java classes provided. JDBC abstraction layer. This helps the developers to handle errors in an easy and efficient way. With this abstraction layer implementation, JDBC programming can be reduced in a web application. Spring Test Context Framework. This framework enables developers to effectively do unit and integration testing for their Spring applications. It provides some key integration testing functionalities such as context management and caching dependency injection of test fixtures. It also supports transactional test management with default rollback semantics. Now that we have explored the Spring features, let's go over the different modules supported by Spring Framework. Spring Core Module. This module is the core component of the Spring Framework, which provides the IOC container. There are two types of implementations of Spring Container. Number 1, Bean Factory, and number 2, Application Context. Bean Factory acts as a central IOC container for instantiating application objects. It also configures and assembles the dependency between these objects. Whereas Application Context acts as a central interface to provide configuration for an application. Spring ORM module. The ORM module is used for accessing data from databases in an application. It provides support for various ORM frameworks such as Hibernate with simple declarative transaction management, resource management, and transparent exception handling. Spring AOP module. Object-oriented programming breaks down the application into hierarchy of objects, whereas AOP, aspect-oriented programming, breaks down the programs into aspects or concerns. They are typically denoted with aspect annotation. Aspects helps developers to implement cross-cutting concerns in a centralized fashion rather than implementing similar logic in multiple places. Spring Web MVC module. This module of Spring implements MVC, Model View Controller architecture, for creating web applications. In Spring MVC, request from the browser goes to a dispatcher servlet, which then sends the request to a controller based on a set of handler mappings. The controller processes the information and returns back the response to the dispatcher servlet in form of a model object. Finally, the dispatcher servlet uses View Resolver to send back the response. Spring Webflow module. This is an extension of the Spring MVC model. Spring Webflow helps in defining the flow between the different user interfaces in an application. It also helps us to virtually split an application into different modules and reuse them accordingly. Spring Web DAO module. This module introduces a JDBC abstraction layer by eliminating the need for boilerplate coding. It supports a programmatic and declarative approach for transaction management and supports easier access to database resources. Spring Application Context module. This is based on the core module of the Spring framework. It supports the features from Bean Factory along with additional features such as internationalization, validation, and resource loading. It also implements the message source interface and provides messaging functionality to an application. Spring MVC framework is used to develop web applications using Model View Controller architecture. MVC is an architectural design pattern that separates an application into logical components for creating loosely coupled web applications. With the MVC pattern, business, input, and the UI logic are maintained separately. One of the key advantages of using MVC is faster development time, where multiple developers work on the different logical components in parallel. Now let's dig in further to understand the three logical components of the MVC framework. Model contains the application data, typically as plain old Java objects, commonly referred as Bojo. View renders the output data from the model in a presentable format. The output would be rendered in the client's web browser such as Edge, Chrome. Controller handles user requests and it acts as a router between the model and the view. Representational state transfer, shortly known as REST, is an architectural style that uses HTTP resources to create REST web services. With Spring's annotations, creating a REST service is quite simple and straightforward. Having said that, there are 4 annotations that are crucial for creating a REST web application. With the MVC architecture, all requests are handled by the controller. The REST controller annotation is used to create a controller component that serves as an entry point for the handler mappings. Any method that is annotated with the response body annotation will be treated as a return value for the HTTP response object. Spring will convert the return value to HTTP response based on the content type in the header. One of the popular content type is JavaScript object notation, also referred as JSON. One of the key classes that represents the entire HTTP response is response entity. All return types along with the corresponding response code can be customized with this class. Request body annotation is similar to the response body. Spring binds the incoming HTTP request to the annotated parameter. It also converts the request into domain object based on the content type in the header. Path variable annotation denotes the method parameter that will be bound to the resource URI. REST API supports all basic CRUD operations. There are specific guidelines defined while making a call to the server, and it is highly recommended we follow them. HTTP GET is used for retrieving resource information only. Since it doesn't change the state of the resources, they are considered as safe methods. The GET APIs produces the same result with multiple identical requests, and this makes them idempotent as well. Some of the key response codes returned are 200 in case of a successful response, 400 when a bad request has been sent or some missing information in the request, 404 which denotes the resource is not found, and typically this happens when you make a wrong API request. HTTP put is primarily used to update resources, but it also creates them if it doesn't exist. If the resource is created, it returns 201, and in case of updation, it will return 200 response code. HTTP post is used for creating new resources only. Post is neither safe nor idempotent, as invoking two identical requests will result in two different resources containing the same information. As the name suggests, the delete method is used for deleting the resources. Delete operations are idempotent, as repeatedly calling the API on that resource will not change the outcome. There are various advantages for creating REST web services in Spring. Let's explore them one by one. Spring MVC follows Model View Controller architecture, where all requests are handled through controller. This enables the separation of logical components for easier development and maintenance. Spring MVC is heavily annotation based, and it allows the developers to add metadata to any of the classes without the need for defining any configurations. Just by annotating a REST controller annotation to the class, Spring applies message conversations to all handler methods in the controller. With REST, representation of data is very important, and hence Spring MVC allows to bypass view-based rendering using response body annotation. One of the main differences between the REST API and a normal web application is that the REST resources are identified in the URI, known as path param variables, whereas in web applications we use query parameters. One of the key aspects of REST web services is that the same resources can be represented in multiple formats. Some of the popular formats are JSON, XML, HTML. Spring uses the corresponding view resolvers to render data accordingly. Similar to response body annotation, Spring supports request body annotation as well to map the incoming HTTP request to the method parameters. It converts the inbound HTTP data into Java objects. Spring Framework provides REST template classes to consume REST services. These are used to develop or test RESTful web services in an easy manner. The main prerequisites for getting started on a Spring framework are a JDK and an IDE such as Eclipse, NetBeans, and IntelliJ. For this demo, we'll be using Java 8 as our JDK and Eclipse as our IDE. Also, I am doing this demo on a Mac, so please ensure appropriate changes are configured if you're doing the same in a Windows machine. So now let's install Java in our machine. In order to do that, open a browser of your choice. For this demo, I'll be using Google Chrome. And go to java.com/en/download. You should be seeing an option called Java Download button in the middle of the screen. Click on the Java Download button. You would be provided with a license agreement. Quickly read them and click on the button Agree and Start Free Download. And this should download the executable file for Java. And once the file has been downloaded, click on the DMG file, which is the Java executable file. And that should in turn open the Java 8 installer. Double click on the Java 8 Update 221 icon. And it will prompt you with a warning. This package is downloaded from the internet. Are you sure you want to open it? Click on the Open button towards the right of the dialog box. If you need administrator permission, please ensure you have administrator by your side to provide authentication to install a software. Once you give the administrator password, click on the OK button. And that should open up the Java installer. Click on the Install button. And that should start the Java installation. And once Java has been successfully installed, you will get a message that says you have successfully installed Java 8 Update 221. And once the installation is done, click on the Close button. To make sure Java has been installed successfully, click on the Apple icon in the left of the screen at the top and go to System Preferences. A new option called Java should be present if the installation is successful. Now that we have installed our Java successfully, the next step is to install our IDE, which is Eclipse for this demo. To do that, first close the System Preferences. Again, open a browser of your choice. I'm opening Chrome. And go to eclipse.org/downloads. I am downloading the latest version of Eclipse, which is a 64-bit package. So click on the Download 64-bit button. Click on the Download button again. And this should download the Eclipse package. Once the package has been successfully downloaded, click on the DMG file. And it should quickly begin the installation. Double click on the Eclipse installer icon. You will see a warning saying that the Eclipse installer is downloaded from the internet. Do you want to proceed? Click on the Open button in the dialog box. And that should initiate the Eclipse installer. Since we would be creating web applications using Java, let's select Eclipse IDE for Enterprise Java developers. The default installation folders would be selected. If you want to change that, click on the Browse button towards your right of the screen. And an appropriate folder can be selected. Once the folders are defined, click on the Install button. Quickly go over the license agreement and click on the Accept Now button. So the installation is completed successfully now. To make sure the Eclipse IDE has been installed successfully, click on the Launch button. And that should in turn open the Eclipse IDE. After opening the Eclipse IDE, the first thing you always will be prompted is to select the workspace. So you can have multiple workspaces for your different projects. In this case, let's create a Spring workspace and launch. And there you go. You've successfully installed Eclipse IDE and created your new workspace as well. Now let's install the additional Spring plugins that are needed to support our development. In order to do that, click on the Help option in the Eclipse tool menu. And you should be seeing an option called Eclipse Marketplace. Click on Eclipse Marketplace. There will be a text box where you can search for the different plugins. Type in Spring and click on the Go button towards the right. Now let's install Spring Tool Suite 4, as all our demonstrations will be based on Spring Boot. Click on the Install button towards your right. And all the default features would be selected. Click on the Confirm button. Select I accept the terms of the license agreements and click Finish. So for the changes to take effect, you have to restart your Eclipse workspace. Click on the Restart Now button. So there you go. We have installed our Spring Tool Suite 4. Now that we have installed Java and Spring Tool Suite to support our Spring development, we also need tools to support the testing of API components. For that, we'll be using Postman. Open your Chrome browser and go to getpostman.com. Click on Download the app. Click on the Download button again, and it should in turn download the Postman zip file. Double click on the zip file, and it should extract the Postman installer. Once the software has been extracted, double click on the Postman. You will get a prompt saying Postman is an app downloaded from the internet. Are you sure you want to open it? Click on the Open button. And there you go. Now you are all set to test your REST APIs using Postman. In this demo, we'll learn how to build a Spring API using Spring Boot. So what is Spring Boot and how is it different from Spring Framework? Spring Boot is an extension of Spring Framework, and it reduces boilerplate coding to a great extent. The main goal of Spring Boot is to reduce development, unit, and integration testing time. So the first step in building a REST application is creating a project in Eclipse. In order to do that, open your Eclipse application first and click on the File option in the toolbar. Then select New and then further select Spring Starter Project. Give a name to your project. For this demo, I'm using REST Demo as the application name, and you can also choose appropriate options for the other fields. In our demo, I'm going with the default selections. Click Next and add Spring Web. So Spring Web is used for building RESTful APIs using the embedded Tomcat container. So once you select Spring Web, click on Next. And then finally click on Finish. A default Spring project called REST Demo is created with all the package structures. Now let's create an employee model with ID, name, and department as member variables within the REST Demo application. Expand the application, and there will be multiple packages in here. Source main Java is where we create all our model and controllers. Source main resources. This is used for creating the view pages as well as application properties. Source test Java package is for creating the JUnit test cases. So now let's create our model. Click on the default package, which is com example demo. Right click on it and then select New Class. Give a name for your model, and for this demo I'm giving employee as our model, and then click Finish. Let's create 3 member variables. I am having ID, name, and department as the 3 member variables for employee model. Select a variable, then right click on it, and then select source and generate getters and setters. That should open a dialog box with all the applicable getters and setters. Select all the variables and then choose the insertion point and finally click generate. So the getters and setters are generated for the model. Save the file, and we are done with the model here. The main component for REST is the controller class. So now let's create a controller class within the same package. Right click on the package, class, and I'll name my controller as employee controller. Click on Finish. So the only way where Spring knows that a class has to be considered as a controller is with the use of REST controller annotation. So once you annotate that, the next step is to create the REST API methods. For this demonstration, we'll be using get and post. So this method is returning an employee type, and it is getting the employee records. And the input for this method is an ID. And the other method is for post, which is for creating new resources. So let's create employee, and the request is the employee object itself. And again, I'm returning null for now. We can change that towards the end. So now that we have defined the two methods for supporting get and post, now it's time for defining the actual request mapping for supporting the methods. So let's start with get. So we have an annotation called request mapping, and request mapping in turn has multiple parameters within it. The first parameter is name, which defines what path the endpoint will be exposed as. So I am giving it as employee. And the next parameter is the method using which this particular Java method would be accessed. And since we created this for get, let's create a request method with get. And there you go. You've mapped request mapping, you've given it a name, and then you've mapped this particular get employee method to get request method. Now it's time to return some dummy values in here. So we'll just return a new employee object. So that's just an input ID. The name can be set to Alex, and department can be set to IT. Let's do the same mapping exercise for post as well. So we can have the same path, and the request method can be changed to post. Now that we have defined the two methods, the next step is to define the request mapping for the methods. The annotation changes based on the type of request parameter as well. So for this case, we would be using request param as the annotation. And for the post, we would be using request body because we are sending an entire object in the body of the method, as we will be using Json as the request format. We'll have to add one more parameter that corresponds to that says this particular method consumes request in the form of JSON. That's pretty much. We are done with all the mappings and the annotations. So now it's time to run this application and then test it using Postman. So starting or running this application is pretty simple. Right click on that application file and then select run as Spring Boot app. Now let's open our Postman application. Enter the URL of the application that's being deployed. We have get here as well. And we are missing one last information here. So in Postman, there is an option called params. There's a key value pair. The key is ID and the value is 1. And then select send. So if you see, the ID got populated from here. Alex and IT are hard-coded values. So in order to test our post method, the first thing we have to change is the request method in the Postman. And for post, it doesn't have request param. It has the request body. So we'll have to remove the parameter here. And there is an option called body below the URI in Postman. Click on the body. And there are multiple ways where you can key in this information. For this demo, I'll be choosing raw, and I'll be typing in the exact employee request. Now, the next step is to change the default format. Right now, it's pointing to text. change it to JSON. If you go back to the header, the content type changed automatically because of the setting that we did in the body. So now that we have set everything, let's click on send. So the response came back. If you go back to your controller class, that's what it did. It just returns it. As I said before, this is just a dummy response. You can have any kind of logic in here. For this case, it's just getting an employee object and it's returning it. So with put and delete, those are the other two REST methods. It's similar to what we have for get and post. It follows the same instructions for creating a REST API. Spring Data provides a familiar and consistent programming model for the developers to access the data store. Some of the key features of Spring Data are reduced boilerplate coding, powerful repository and custom object mapping abstractions, easy integration with other Spring modules, and dynamic query generation from the method names. Also, Spring supports a wide range of persistent stores. Relational databases, where data is structured and maintained in tables with columns and rows. Non-relational databases, on the other hand, contains unstructured data and is stored in the form of documents. One of the most popular format is JSON. MapReduce frameworks, which process vast amount of data in parallel on large clusters. And finally, various cloud-based data services offered by Azure, Amazon, and Cloud Foundry. Before getting into Spring Data Java Persistence API, let's quickly understand what JPA is. JPA is an object relational mapping standard created for Java to store, access, and manage objects in relational database. Spring Data adds an additional layer on top of the JPA to make developers' life easier for seamless integration with other Spring modules. JPA also reduces boilerplate coding, where the developers can concentrate only on the business logic rather than configurations. Now let's explore some of the features of Spring Data JPA. Spring Data supports type-safe JPA queries that enforces data type validations. It provides support to transparently keep track of who created or changed an entity and the point in time this happened. Pagination support, where data from large result sets is returned in chunks based on the page size and numbers. Dynamic query execution using APIs such as JPA criteria. And finally, along with annotations, Spring also supports XML-based entity mapping in a configuration file. Spring Data provides consistent repository abstractions for Lightweight Directory Access Protocol, shortly referred as LDAP. LDAP directories are hierarchical data stores used for storing user information to support authentication and authorization. Now let's dig in further to understand some of the features offered by Spring for LDAP. Spring Data provides configuration support using the configuration class as well as XML namespace. It supports annotation-based metadata mapping. Spring Data supports custom query methods along with automatic implementation of repository interfaces. And finally, it integrates well with Query DSL to support type-safe queries. Spring Data provides extensive support for integrating well with Elasticsearch search engine. Spring's Elasticsearch uses POJO, plain old Java object, for interacting with the Elasticsearch documents and for easily writing a repository-style data access layer. Some of the key features are configuration support, both annotation and XML-based, object mapping integrated with Spring Conversion Services, automatic implementation of repository interfaces, and context and dependency injection support while interacting with the repositories. Spring simplifies developing Apache Hadoop using a unified configuration model and easy-to-use APIs. It also provides integration with other Spring projects, enabling the developers to building solutions for big data. HDFS is a distributed file system that provides high-performance access to all the data across the Hadoop clusters. MapReduce is a framework supported by Hadoop for processing huge amounts of data in parallel. Apache Pig is a platform for analyzing large sets of data that consists of high-level language for expressing data analytic programs. Apache Hive is a data warehouse for providing data query and analysis. It provides a SQL-like interface for querying the data stored across different file systems and databases. In this demo, we'll read and write data to an embedded database using Spring Data JPA. The first step is to create a project in Eclipse. In order to do that, open your Eclipse application and click on the File option in the toolbar. Then select New, which should present you with further options. And then finally select Spring Starter Project. Give a name to your project. For this demo, I am using Spring Data as the project name, and choose appropriate options. Click Next. Add Spring Web, JPA, and as well as Embedded H2 database. Once you add all the options, click on Next, and then finally click on Finish. A default Spring project is now created with all the dependencies. I already have the base controller and model defined for this project. Let's quickly review them and proceed with the Spring Data JPA configurations. So let's expand on the project. And we have an employee controller here, which is a REST API controller. This is a get method, which is to fetch the employee details. And this is a post method for creating new employee records. That's with the controller class. And with the model, it's a simple employee bean with ID, name, and department as member variables. So now the first step in configuring a Spring Data JPA is to create an entity class. So let's take our employee model and then change it to an entity. And we can do that by simply annotating entity to the class. Let's import entity for javax.persistence. And every entity class corresponds to a table, and we should define an ID for the entity. So in our case, there's already an ID member. So let's annotate that with ID. If we also want the ID to be an auto-generated value, we have an annotation for that. We can just give generated value, and we can give a strategy for that. So this is an ID that will be automatically incremented. That's what this annotation means. Once these are defined, we are good with the entity. And if you don't give any column names to any of the other variables, the exact variable names would be used, and that would apply for name and department here. The next step is to create a CRUD repository interface. In order to do that, right-click on the package, click New Interface. Let's give an employee repository interface. And this interface extends the default CRUD repository. And we'll have to define what is the parameter type and what is the ID type. In our case, the parameter type is an employee object, and the unique value is the ID, which is of type long. And we can denote this repository with a repository annotation. So now we have successfully created the CRUD repository. So this repository totally eliminates the need to have individual data access objects along with its implementations. Now let's move on to our controller class. Now let's auto-wire CRUD repository. So what this one does is we are letting the Spring container to create the instance for this particular object. And we can use that to return the result. So to find all, I'm going to return all employees, and I am removing the parameters. So what this API is going to do is return all the employees. We can save the object to the database, by passing the employee entity. And then return the same employee object here. Now that we have auto-wired this object and updated both the methods to save the data as well as to fetch all the data. Let's run the application now using the Spring Data application that was created when we initially created the project. Right click on that and select Run as Spring Boot application. The application is started successfully. Now open Postman. Add a request URI, which is localhost. And this is being deployed under Spring Data. So give the same name as the root. And the individual method is employee. You can find that in the controller. And first, let's try to insert records and then fetch them. So for inserting the records, we have to use the post method. In the body, you can give the name. Department IT. Mark it to JSON. If you hit send, it should be returned back with an ID. So the object got saved into the database successfully. Now let's have the same user and allocate him to the other department as well. Let's say HR. And again, when you hit send, another record should be created with an ID of 2. Now that we have inserted both the records, let's try to fetch using the get method. Select the request method as get. And if you look at the controller, it uses the same path for get as well. So if you hit send, it should return both the records. There you go. So with this demo, we were able to read and at the same time write data into a database. Spring Security is a Java Enterprise Edition framework for securing enterprise Spring-based applications. It focuses on providing both authentication and authorization for Java applications. One of the biggest advantages of this framework is that it is highly customizable. Some of the main features of this framework are comprehensive and exhaustible support for both authentication and authorization, very easy to integrate with servlet APIs, protects the application against attacks like session fixation, clickjacking, and cross-site request forgery, and supports integration with other Spring modules such as Spring Web MVC. What is authentication? It is a mechanism to verify or establish your identity. One of the most common ways of achieving this is user credentials, such as a username or ID with a password. There are various forms of authentication. Single-factor authentication is the simplest form of authentication method. It just requires a password to authenticate the user. Two-factor authentication is a two-step verification process which requires not only a username and password, but also another piece of user information. One of the most common examples of two-factor authentication is a username and password along with a verification code sent to your mobile device. Multi-factor authentication is the most advanced level of gaining access into a system. It requires 2 or more levels of security from independent categories of authentication. It is common for bank institutions to use username and a password along with one-time passwords sent to mobile as well as email IDs of the user. Authorization occurs after your identity has been successfully authenticated by the system, after which you will be given full access to the resource. It is the process to determine whether the authenticated user has access to particular resource or not. One of the best example is employee login, where a junior level employee is not authorized to view resources applicable to management team. Now let's look at some of the core concepts in authorization. Access control is an additional step from authentication and authorization to protect specific segments. Spring has the ability to secure resources at object and method level based on user grants and privileges. An access control list is a list of permissions attached to an object. It helps in defining user permissions on a single object rather than the entire system. Spring supports security with OAuth 1 and OAuth 2 protocols using security programming models and configurations. OAuth providers refers to a HTTP server that understands OAuth protocols and at the same time can handle authenticated requests from various client applications. OAuth consumers refers to the applications that is trying to gain access to protected resource on behalf of the resource owner. This can be a service, browser, or a mobile. Spring supports OAuth 1.0, where the consumer will first get the request token and then in turn use the same to get authorization from the provider. None of the resource owner's credentials needs to be stored, and at the same time, the resource owner has full access and control over the transactions. Upon authorization from the resource owner, the request token is exchanged for access token, and finally the connection is established. With OAuth 2.0 protocol, this is simplified, where the consumer will directly request authorization from the service provider and then in turn use the received grant to exchange for an access token. Typically, with OAuth 1.0, tokens can be stored for longer periods of time, whereas OAuth 2.0 tokens are short-lived and can be renewed with the concepts of refresh token. Spring Security allows seamless combination of SAML, security assertion markup language, authentication, and federation mechanisms in a single application. It supports SAML 2.0, which uses security tokens containing assertions to pass the principal user information between the service provider and the identity provider. Spring can process all the SAML attributes and has support for mapping them. Single sign-on is an authentication mechanism that allows a user to log in into multiple systems with one set of user credentials. With IDP-initiated single sign-on, federation process is initiated by the identity provider sending a SAML response to the service provider, whereas with service provider-initiated single sign-on, the service provider first generates an authentication request that is forwarded to the identity provider, and then the IDP returns the SAML response. Service provider metadata contains keys, services, and URLs defining the SAML endpoints of the application. Spring supports automatic metadata generation by enabling the metadata generation filter. In this demo, let's learn how to secure a web application using Spring Framework. I have already created a Spring Starter project with security, web, and Thymeleaf to support view pages as dependencies. Let's quickly review them one by one in the project. In your Eclipse application, expand the project. Let's check the pom.xml first, which should contain all the dependencies. So we have the security, Thymeleaf, as well as the web dependency mentioned here. Now let's check the MVC configuration, which is an mvc-config.java within com.example.demo package. The MVC config implements the web MVC configurer. This is used for configuring and redirecting the request to the different view pages. For instance, if your URL contains /home in the request, the dispatcher servlet would forward us to the home view, which again corresponds to an HTML file in the template folder. So let's look at the template folder, which is under source main resources. These are the 3 default HTML files that I created for this demo application. Now let's run this application without security and understand the behavior. So let's start the application. You can do that by right-clicking on Spring Security Application.java, which gets created when you initially create the starter project. Right-click on that and click Run As, then select Spring Boot App. It should start the embedded Tomcat container. Let's open the Chrome browser and go to localhost. And this takes us to the home page. And if you click here to go to the dashboard, it takes you in directly. If you notice, anyone can get into this application without proper security or authorization. This is where Spring Security helps us. So let's go back to the Eclipse. So the first step is to go back to the pom.xml file and bring back the security dependency, save it, and then go to the MVC configuration file. Let's add the web security here, and that can be done using enable web security. Once that's done, the next step is to create the web security config class, which will extend the web security configurer adapter. This is where we define all our security configurations. So right click on the default com.example.demo package, new, and select class. Let's create a web security config class. And since this is a configuration class, let's annotate with configuration. And also let's enable web security for this configuration class as well. This class will extend the web security configurer adapter. Now we have to override the configure method for the custom security to kick in. So let's do that. So I'm adding a new method called configure. And this takes HTTP security as the input. Let's annotate this with override. And this method throws exception. Now that we have overridden the method, the next step is to configure the authorized request, the form login, as well as the logout. In order to do that, we can use the input parameter, and we can just add authorized requests, and then we can do a match. The Spring Security has ant matches where we can give, if this URL is of a particular pattern, don't ask for any authentication, and if not, request authentication. In our case, we don't want users to be authenticated when they are trying to access the home screen. So let's do an ant matches with the pattern. So anything that's a slash or a slash home will be permitted without any authorizations. And any request has to be authenticated. And we will also add a form login to say where our login page is. So this one goes back to our view name, which we have already configured. And this corresponds to the same name as the HTML file in the template folder. And then just give a permit all. And finally logout.permit all. So that's our basic configuration that states anyone who's trying to access the home page or the root page would be allowed to access the data or the page without any authorization. Otherwise, they would be requested to log in, and whenever a login request is needed, it will redirect the users to this particular login view. Now let's create a default user and a password to access this application. In order to do that, let's again override the same method, but it will have a different request parameter. We can use the Authentication Manager Builder, and this method would throw exception. So let's do an in-memory authentication and then set the password encoder. So we'll use the bcrypt password encoder here. And let's add a user. Let's set the username as user and set the password to an encoded password. So for that, we'll again make use of the bcrypt encoder. Let's give a dummy password here. And then let's finally set a role to this particular user. We'll have a default role of user. So we just built a profile for this application with username as user and password as ABCDE12 caps A. Save the application. Now you have enabled Spring Security and secured your web application as well. Let's restart the application. Right click on the Spring Security application, click Run As, and select Spring Boot App. That should bring up the embedded Tomcat. Go to Google Chrome. Again, go to localhost. It'll be taken to the initial screen, and then click on the Here link to go to the dashboard. Right now, since you've enabled security, this should take us to the login screen. There you go. Now our application is protected, where any user who doesn't know the username and password will not be allowed to access the dashboard page. So let's give user and an invalid password, ABCDE1. So it didn't let us in. Now let's again give a valid username and password. It should take us to the dashboard screen. So we have successfully configured Spring Security for our web application. Beans are key concepts of the Spring framework, and it is the backbone to your application. A bean is a very simple object that is instantiated, assembled, and managed by the IOC container. So what is an IOC container? Why do we need them? And can we just instantiate a bean object the traditional way? These are some of the questions you might have right now. Now let's do a deeper dive into IOC before proceeding further. Inversion of control, shortly known as IOC, is the process in which an object defines its dependencies. That is, the other objects they work with, either through a constructor argument or a simple property. The container then injects the dependency when the bean is being created. This process is fundamentally the inverse, hence the name inversion of control container. IOC is also known as dependency injection, where we let the Spring container to instantiate objects. Bean Factory interface is the central IOC container interface in Spring. It is the actual representation of the Spring IOC container responsible for managing the beans. The most commonly used Bean Factory interface is the XML Bean Factory class. Spring configurations consist of at least one bean definition that the container must manage. Typically, there'll be more than one bean definition with the XML configurations, and these beans are configured as elements in the bean tag. The configuration metadata informs the Spring container on how to instantiate, configure, and assemble objects within your application. The configuration metadata is maintained in XML format. Instantiating Spring IOC container is straightforward and can be achieved with the use of application context. Spring also supports annotation-based configuration for bean creation. Bean definitions are represented as bean definition objects, which contains a qualified package name, which is the actual implementation class of the bean being defined. Bean behavioral configuration elements, which states how the bean should behave in the container. References to other beans which are needed for the bean to do its work. These references are also called collaborators, or dependencies. Other configuration settings to set in the newly created object. One of the best example is managing a connection pool. Before getting into bean definition inheritance, let's quickly understand what inheritance is. Inheritance is an object-oriented programming mechanism where an object is created or derived from another class, which is usually a parent-child relationship. A bean definition potentially contains a large amount of configuration information, including container-specific information, constructor arguments, and property values. A child bean definition, on the other hand, is a bean definition that inherits configuration data from a parent definition. Child bean definitions can override values if needed. With a bean factory, child bean definitions are represented by the child bean definition class. Most developers configure bean declarations in the XML bean factory. When using XML-based configuration metadata, a child bean definition is indicated simply by using the parent attribute. Some of the configuration information for bean definition inheritance are scope, constructor arguments, properties, and overriding methods. A child bean definition will use the bean class from the parent definition if none is specified. But at the same time, it can also override it. Child beans have to be compatible with the parent. It will inherit constructor argument values, property values, and the method override from the parent. It also has options to add new values if needed. When a bean definition is created, we are actually instantiating a class. Along with dependencies and configurations, Spring allows us to control the scope of the application as well. Spring supports 5 different scopes. Let's explore them one by one. With singleton scope, only one object instance will be created for the single bean definitions. Prototype scopes a single bean definition to any number of object instantiations. Request scope is valid until the lifecycle of single HTTP request. Each and every HTTP request will have its own instance of the bean. Session scope works throughout the lifecycle of HTTP session. One of the best example of session scope is when a user tries to log in into an application and the session is valid until the user decides to log out or close the application. Global session scopes a single bean definition to the lifecycle of a global HTTP session. This is only valid when the web application is under the application. This demo is for understanding how to use Bean Factory for creating Spring Beans. I have already created a sample Spring Boot project with the default Spring Bean definition file. Let's explore the project first before proceeding to the Spring Bean definitions. After creating a simple Spring Boot project with no extra dependencies in your Eclipse workspace, expand your project and expand source main resources folder. This is the Spring Bean definition skeleton file. It just has the base structure for defining the bean. We'll add more information later when we get to this part. Now, the first step for a bean definition is the actual bean. So what we can do is create a simple bean inside source main Java. Right click on the com.example.demo package and select new class. Create a bean called profile and then click finish. We'll have 2 member variables in here. Both are string, name and role. Now let's generate the getters and setters for these variables. Right click on one of the variables and then select source, generate getters and setters, and then select all the appropriate variables. Decide the insertion point and then click generate. So now we have the getters and setters, and we might also need constructors because beans allow constructor arguments as well. Let's quickly create a constructor. This is the default constructor and the other one is the overloaded constructor, which takes in both name and role. So we have successfully created the simple Java bean. The next step is to create the bean definitions within the bean definition file. Let's go back to spring-bean.xml file. We have the bean skeleton here. Let's add a new bean where the ID is profile, and we have to give a corresponding class as well. The class should be qualified. That's the class name. Since we have constructor arguments, let's define both the constructor variables in here. So it's a constructor argument. Name is equal to name, and value is Alex. And the other constructor argument is role for this particular bean. Let's give name as role and value as user. So now we have successfully created our profile bean, and we have also set the constructor arguments for both the member variables name and role. The next step is to access this bean definition file from our application. Let's go back to the Spring Beans application.java file. So right now this is set up to run as a Spring Boot application, which loads all the context based on the container. Let's remove the default load and add our own application context. So we'll add a class path XML application context, and we'll have to give the name of the bean definition file. In our case, it's spring-bean. And it is in the class path since it is inside the resources folder. Now let's create a factory. So bean factory. So we'll set it to that bean factory. Next, we will be getting the bean, which is profile. Factory.get bean profile, which is the bean name. We'll have to add a quick cast to profile, and then let's print the name, and this should print Alex based on the value that we have defined in the Spring Bean XML file. Right click on this application file, run as Spring Boot app. There you go. So we have successfully configured bean definitions using XML factory. Also, please note that Spring recommends the usage of bean annotation for faster development rather than XML configurations. Spring MVC is a Java framework for building web applications, and it is based on the popular Model View Controller design pattern. Along with the web features, it also supports the core functionality of Spring Framework, such as IOC and dependency injection. So what is MVC design pattern? Model is typically your application data. It can be a single or collection of objects. Controller acts as a router between model and view, and it contains all the business rules of the application. Any class marked with controller annotation will make it a controller class. View is what you see on the screen. It represents the information in a particular format. JSP is an example for creating a view page. Dispatcher Servlet works as a front controller, and it is totally responsible for managing the flow of Spring MVC applications. One of the key components of Spring MVC is the Dispatcher Servlet, and it is a class that receives all the incoming requests and maps it accordingly to the model and the controllers. So how does a Spring MVC execution flow work? First, the Dispatcher Servlet receives the incoming request, and then the Dispatcher Servlet identifies the controller class based on the handler mappings. Once the controller has been identified, the request gets processed and returns model data and the exact view name. Then, the Dispatcher Servlet sends the model data to the view resolver to determine the view page, and finally, the Dispatcher Servlet renders the results in a view page. Now let's explore some of the key advantages of using Spring MVC. With the use of model, controllers, view resolvers, and Dispatcher Servlet, Spring MVC defines separate roles for the different components. It provides a robust configuration support for context references, web controllers, business objects, and validators. Spring MVC uses a lightweight servlet container to develop and deploy your application. With all the easy configurations and reduced boilerplate coding, Spring MVC facilitates faster development. With the help of Java Beans, we can test easily by injecting the test data using the setter methods. One of the main advantages of using Spring MVC is reusability. Instead of creating new objects, Spring MVC allows us to use existing business objects. With the help of annotations, mapping the configurations and redirections are very straightforward. Every framework has its pros and cons. Now let's look at some of the disadvantages of adapting to Spring MVC framework. If the developers don't understand the core concepts of Spring, such as IOC and dependency injection, Spring cannot be used to its fullest extent. So there is always the possibility of learning curve. Spring keeps changing over time, and it is not easy for everybody to adapt to the latest changes. Spring promotes dependency injection, so if you start using Spring, your entire project will be dependent on Spring Framework. And because of enforcing this dependency, your project will not be able to come out of it if needed in the future. In this demo, we'll be creating a Spring Web MVC application. There are three main components in MVC. The first is model. Let's create a user model with username and password as member variables first. In order to do that, create a simple Spring Boot starter project with Spring Web as one of the dependencies. Once the default project is created, expand it, and all the default package folder structure should be there. Expand source main Java, and there'll be a default package called com example demo. Right click on the package, and let's create a new model. So for our demo, we will be creating a user model which has two member variables, which is username and password. Let's generate the getters and setters. Right click on any of the variable, select source, generate getters and setters. Select all the corresponding variables and then click generate. The getters and setters are generated successfully. Now that our model is done, the next step is to create a controller class. In order to create a controller class, again right click on the same package, select new, class, let's give user controller as our class name. In order for Spring to consider this particular class as a controller, we'll have to annotate it with a controller annotation so that Spring knows. And we'll be creating two methods here. One is the landing page and the other one is the dashboard page. Let's quickly do that. And both of these methods would be returning back the view name based on the request mappings. and this would return a view of login. So there has to be a corresponding view page that has the same name as login. And now let's define the request mapping. In the request mapping, this particular method should correspond to the path login, and the method request method is get. So we've successfully defined the landing page. So what this method does is whenever it sees /login in the request URI, the user will be redirected to the login view. Now let's define the dashboard page, which has almost the same mappings. And let this be post. And there'll be other informations in here. So this is when the user keys in their information, username and password. When they click submit, the request comes to the controller, and at that point of time we do have access to the user object, hence we are capturing that in the request. And the next is the model attribute. So this will be really helpful if we want to set some values in the controller and then pass it on to the view page. So we will import the UI model in here, and this would return dashboard as the view. And the model can be used to set an attribute. So we can have an attribute name as username, and attribute value is user.getUsername. So the model is set, and we are returning the view to dashboard. The controller is done now. The last component is the view page. Before proceeding to the HTML files, let's quickly make sure TimeLeaf is added as one of the dependency in the POM file. So open the pom.xml file. Since we initially created the project with just Spring Web, TimeLeaf is not one of the dependency here. Let's quickly add TimeLeaf as the dependency. The Maven should resolve this automatically. Now, going back to the two HTML files that was already created. The first is the login.html file. This one takes in username and password, and upon signing in, the flow goes to dashboard, and we have already defined a controller mapping for dashboard, and that in turn saves the username in the model and goes back to the dashboard view. And we have a corresponding view, dashboard.html as well. And finally, we will be getting a message, welcome the username that we are giving in the text box. Now it's time to test this application. Right click on the MVC application that was generated, and then select Run as Spring Boot app. It should start the embedded Tomcat container. It's up and running now. Open your Google Chrome browser and go to localhost 8080. So you see your login page now, and this is what we wanted to see as well. Now let's give a username, Alex, and a dummy password. Now upon clicking sign in, the control should flow to the dashboard page where the user must see a welcome message that says welcome username, and in this case it should say welcome Alex. Let's try that. There you go. Now we have successfully created an MVC application using Spring Boot. So in this course, we've examined the key components of the Spring framework and how they are used to create enterprise Java applications. We did this by exploring the components and features of the Spring framework, and how to install and configure the Spring Framework environment, how to build a REST API using the Spring Framework, the Spring Data component, and how to use the Spring Data JPA module to access and write data to a database, the components of Spring Security and how to use it to secure an application, Spring Bean and how to use the Bean Factory to create beans with the Spring Framework, and the features of the Spring MVC framework and how to use it to create a simple web application.